Oh, I thought you.
I did, yeah. It's fine, I think. Oh, yeah, I do, yeah.
Okay, so I have these two here.
Okay.
Done, we're doing a handout later.
Here, otherwise you.
No, I don't know what you plan on doing.
Okay.
Like, we don't have.
Let me. They're working.
Yeah, where you just need to press it. If it's red, it's off.
Yeah.
Just press the button.
My dad's the good out now, he does.
This one, right?
Yes.
You have to leave early, right? It's okay, I do PDF instead of PowerPoint.
Okay.
Have to do PDF.
Okay. Yeah, you can, you've got to.
Okay. Yes. I just have to make everything PDF.
Oh.
The PowerPoint will take forever to open.
Well, maybe just the first ones.
No, it's done.
We should start in one. Oh, it's done already?
Yeah, everything is
Okay,
done.
yeah.
No.
Just the second one, aging dementia one.
Yes.
Aging dementia. Artem said he will bring updated slides in between breaks.
Okay.
Start.
Yeah, we should. Okay, it's time.
Please sit down.
Right, we can start now. We can start. Right. I think,
Arman is here, so I'll
oh,
introduce.
where is Armin? Oh, Armin's here, but forward. Or reusing his.
Was here for sure.
Was it a minute ago?
Yeah, yeah. I talked to.
Oh, hey. Oh, big him. Because we very tight.
Yes.
Oh,
I know you have to start with Jeff.
Okay, right. Movie.
Office.
All right, this work. Okay, let's get started pretty soon. Let's sit down.
Hello?
We can always do it afterwards. Right, and is the streaming work? Oh, yeah. All right, let's just get started. We'll have Anastasia.
Great. Oh. So hi, everyone. Welcome. So today we have AI and longevity showcase with R42 Group and Perkins Coie. So thanks to Perkins Coie for hosting us. And a little bit about myself and R42. So I'm a principal at R42. I've been there from before R42 was launched. And R42 is a fund and an institute. And we focus on AI and deep tech and longevity biotech companies. So intersection of computer science and biology is our sweet spot. And it is my pleasure to also introduce to Arman, who is a partner at Perkins Coie, international leading international law firm, and he is a really great friend of and a legal counsel of R42. So I'll hand it over to you.
Thank you so much, Ranjan. Hello there. Anastasia, thank you. Thanks for making the introduction short about me. I appreciate that. So, welcome everybody. I'm delighted to have all you guys here and ladies here. Some new faces, a lot of old faces, so it's fabulous. Ranjan, congratulations with yet another fantastic event to be started in connection with this San Francisco Tech Week. It's been a busy week for us in our San Francisco office, and I'm glad we're doing it down here. It's kind of a zoo up there. So I just wanted to say a couple of words about the firm, myself, and about Ranjan, most importantly. So Perkins Coie is an international law firm. We have offices in Europe, Asia, and the US, about 20 offices. I think the last count I had 21 offices. Boeing Corporation was our first client, believe it or not, 110 years ago or so. And, we incorporated Amazon, and we've done Caldera. We incorporated Zillow and Trulia and many other companies. And, we really believe in representing companies that have momentum in the world of technology. That's kind of our sweet spot. And Ranjan and I have known each other for probably 10, 11 years, 12 years or so. He's one of the most brilliant people I know. He's one of the most genuinely kind and generous people I know. So we talk about the real positive issues first. And aside from that, Ranjan is absolutely brilliant in the world of machine learning and AI and computer vision and many other things. He was recently inducted to the Silicon Valley Hall of Fame, and I was, lucky enough to be at that event. Thank you for inviting me, Ranjan. He also is an adjunct professor at the Stanford School of Medicine in the genetics department, is where he's mostly active. And sometimes he calls me to go and give a lecture on some issues of M&A and financings and stuff. Just a couple of words about myself. I work in the broader aspect of private equity in terms of forming funds, which is where it all starts. I do that work, and then we represent the companies or the funds in their activity, starting from minority investments, which is most of venture capital, then private equity, which is the controlled investments or M&A, and taking it public, and we join as the counsel for the company to do all that work. So, Ranjan, it's your show. I can't wait to see all the wonderful things that you have here. So please come on in.
Thank you very much. Ranjan. Thank you, Arman. That's great. As I said, we've known each other lots of time, done loads of deals together. And if anyone's interested, and they have great deals for startups if you want, and female-led startups as well, special extra deals, right? Is that allowed? Is that legal? Different. My startups, that's right. Specialties for my startup, even midway through, right? And I think that is one in half seriousness. One thing is, so I've met lots and lots of law firms around the valley. When the going gets tough, the tough get going, and Armand's one of those guys. And I've seen other, even at tier one law firms, where they kind of like drop the companies, and that by definition increases risk. So I'd like to give credit to Perkins as a firm. Obviously, he needs support from the firm as well to do that, to keep working with companies. So it's not when you start; it's in the middle. That's the tough. So I'm going to just go through very quickly. How long have we got? We've got about 10 minutes or so, right? Okay, right. We're going to go very quickly with what R42 is. We've got a packed agenda. Now you've all seen this. It's going to be each company's going to. Some of these are companies that we've invested in. Some of these are just ideas that we have been looking at, and I thought it's interesting to have in today's session. This is me. I've been working literally AI for 40 years, and that's proof. No Nobel Prize, unfortunately, but there's two Nobel Prizes that are announced this week in AI for those of people who are monitoring that, but lots of other things. And looking at things so R42, we're a venture firm. We're also an institute. I also teach lots of courses at Stanford. They're really Stanford's cheapest courses. They're like $400, and you don't have to pass an exam to get in. So I recommend that. And the thing is with aging, this is the sort of current sort of profile of demographics. People, lots of young people, and not very many old people. And that's really going to change, where there's going to be roughly similar amounts in every age range. And that's going to have investment opportunities and technology and product opportunities. And driven by technological advances, certainly AI, you're seeing that pretty much every hour, but also biology. But many biological advantages, they sort of terminate at 122, 120. This is Jean Coleman. She started smoking at age 112. She was quite social. She's not around anymore. People didn't believe that she was actually her. It might have been her daughter. But it turns out with Providence checking, it was actually her. She did actually live till 122. Unfortunately, the person who, Maria, got to 117, she died like 6 weeks ago. And Tomiko is now the oldest person. She's 116. Okay, so we get this 116, 180, 120. That seems to be a termination. You're going to have to do something different other than push-ups and diet and exercise. And we'll hear some of that from today's speakers. Aging is not linear. 44, 60, 80 are key breakdown points. This is work that's done at Stanford by my colleagues Mike Snyder and Tony Weiss-Coie, looking at these various things. And people are looking for things. Can you change one thing that fixes all things at the same time? And R42, we're really looking at things that attack the inflection points of aging. There's many, many different things. Many of these companies focus on their one thing, and we want them to. But what we do is really cut across these so-called hallmarks of aging. So put it in a portfolio aspect. And so it's kind of like, almost like running a company, but we're running it in a fun basis. But I'll tell you, we are trying to get moonshots out of these companies. And moonshots, and some of you have done moonshots yourselves. I can see several of you here. You've actually been through that process where people say it's not possible. You can't actually do it. And I think from an engineering point of view, you can do things. When JFK gave approval for landing on the moon, his advisor said it was going to be possible, difficult, but possible. As engineers, we have to work backwards. Now, let's look at flight. I could have used electric cars. Mark's over there. I could have used robotic exoskeletons. Kern's over there. But this is 1901. Flight is impossible. It's just impossible. 1901. 1903. It would take 10 million years of human mathematical calculations to end up in flight. New York Times, 1903. And 9 weeks later, the Wright brothers fly, but they didn't fly very far. know, 100 feet. When you see that demo, you'd say, okay, so that's a demo, it's a prototype. Who cares? 1952, we're doing mainstream commercial flight. Anyone can buy a ticket. It's a little bit pricey, but people can do it. And now, you know, you can go to Hawaii for $300, and the opportunities for a poor person today, more than a millionaire in 1850 for entertainment and travel. So Agemica is one work project I'm working on, you know, and we're trying to do a vaccine. A vaccine for what? A vaccine for aging. Sounds impossible. Sounds impossible, but maybe with some of the ideas we've got in some of our portfolio, Agemica itself is trying to do it in an engineering way and say, can we use machine learning to look at clusters of diseases? First of all, a cancer vaccine, a cardiovascular vaccine, etc., and go step by step. So breaking down a problem to small bits. And now this vaccine idea is out there. And we're starting with cancer at Agemica. And 1 in 2 people over 60 get cancer. If you get to 80, actually the prevalence becomes lower, but that's probably because everyone else has died off. And cancer might be the same as aging. Your immune system is not clearing out your cancerous cells. And if you can actually beef up your immune system, and there are numerous ways to try and do that, can you actually do that? And so what Agemica is trying to do is 3 tricks, because I haven't got 25 years to invent this. We do it by not inventing other drugs, use existing drugs. It's called repurposing. And because the existing drugs already exist, then it will be safer, faster, and we can get through to a higher probability of success. Now, everyone's asking me, what do I do? So here are tips for aging reduction. Now, my favorite test is a telomere test. It says I'm 20. And the Olay Skin Advisor, unfortunately, says I'm 52. So even though I am actually 20, I still look old. That's the problem. That's my proof. It's my telomere test. Of course, in longevity circles, people tend to think that's more of a correlation than causation. But I like that test because it says I'm 20. But I do running. If you can still run, it's probably the most efficient way to maintain a healthy lifespan. And that's my time. So it is kind of like equivalent to a 20-year-old. It's 8 miles in 50 minutes. That's a 6:15 pace. But it's not really necessarily I've got young. There's a big training effect, right? It's obviously 10 years of training to get to that level. And those of you who are interested in more longevity, there's a conference in January, JP Morgan Week. And that will be, the tickets are cheaper if you do it before October 31st. So let's get to the first speaker. Oh, by the way, if you still want to talk to me, you can talk to my avatar here. This is, it says almost what I would say in real life. And we should get you one, Armand. We should get you an avatar. Yeah, you just upload your PDFs, everything you've written, and then you start giving legal advice. Actually, half seriously, because in my classes I have 300 students. I can't give office hours to everybody, so they actually use this quite easily. Okay, so we've got the first speaker, which is sorry, Johnny, right? Yes, great. We're going to have Johnny Adams as the first speaker, and the next presentation. Can you move to the next presentation? Oh.
Okay, my 15 minutes of fame begin right now. Okay, first, big thanks to everyone who helped make this event an outstanding success. And a special thanks to Armand here at Perkins Coie. I think I got that pronunciation right. All right. Now look, why I'm staking my life on the 3 most effective age reversal therapies to be young again. And I'm going to rip through a lot of material very quickly. We can get together and cover all this at a much more leisurely pace. Just go to agingintervention.org And there's a sign-up sheet on every page, and we'll take it a lot slower and more conversational. So we're going to get to some science in a moment, but first let's start with the fundamentals. What do we call it? Life extension goes back many decades. Some other terms, health span, lifespan, some new terms here. I coined the phrase open-ended life. No expiration date for you or for me. And of course, it's healthy and vibrant and living with gusto and all that, and making the world a better place. That's part of the deal, okay? Now, in conferences like this, aging is usually described in clinical, I think of them as rather sterile terms, and words like risk factors and hallmarks are used, and that's important as a scientific foundation. But my friend, this is what it looks like and feels like to get old. And this is what I'm going to do about it, with a little help from my friends, and conversely, by helping my friends. And we're all inclusive here. AI generated this. The theme of this conference is AI and longevity. And this is what AI says is a suitable endpoint. So, okay, I won't disagree with that. Okay, now, for right now in my world, it's about these things on the left. Being young, and they're priceless. You can't put any sort of price tag on it. However, with the right management, there's an opportunity for these things. I mean, imagine the possibilities. Your own spaceship, your own Meta AI glasses. I got these, they're kind of cool. Your own Tesla robot greeting you as you come back from space, asking you, "Hi, honey, what'd you do today?" "Oh, I went out to space." "Did you have a good time?" Yeah, dinner's ready." Okay. Anyway, okay, I'm Johnny. I've been working on this aging thing for well over 4 decades and researched a lot. Mostly what I do is pilot proof of concept studies and a lot of other things. And I'm here to tell you, it's within our grasp. It's like AI is on an exponential curve like this. Health span, longevity, life extension, whatever you call it, is going to follow. I do a lot of writing. I do things. I share it with the world, no charge. Wish I had more time to go through a lot of these, but we have a YouTube channel. We interview and have really high-level speakers. Aging intervention program, system therapies, metrics. There's a lot of talk about a thing called a blueprint these days. That's my blueprint. It's on the website. I give it away. Here's our deal. My offer to you: help me make these therapies happen fast, and I'll do everything I can to make you young again, or to make whatever it is you want to make happen. I'm a very loyal friend, a great partner to have. You help me, I'll help you. We work together, lockstep, solve this aging thing. Ranjan reminded me that there are different models that we can operate under. The first one is a nonprofit philanthropy model and a for-profit business model. I suggest that there's a third, among others, a self-preservation model. I'm glad some of you get that. I operate on all three, but I really lean towards the third one. I love life. Give me more. And this one I actually removed, but I just had to put it back in. AI generated this. Look at all those people, their expressions. AI did that. It was a darn good prompt. Now, I'll leave it to your imagination what was removed there. I wanted to be polite. But regarding these models, this is my nonprofit foundation. This is a recently formed for-profit foundation. I work closely with Bill Falloon and the Age Reversal Network. Bill Falloon has put in millions of his own money to make age reversal solutions happen. And these are several of the other organizations that I have a leadership role in. parts of the therapy, and we have a very sophisticated crowd here, but still, I suggest to you that parts of the therapies I'm going to show you today are far beyond what you've been seeing. And a big point, please remember this one, is that unlike most therapies and even combinations of therapies, the ones I'm going to show you affect an extremely wide range of therapeutic targets and hallmarks. I'm going to abbreviate this. They fix stuff that a person over the age of 70, like myself, doesn't have the capacity to fix. So sure, for now, we continue running, nutrition, exercise, the conventional common sense things, and then maybe under expert doctor's guidance, metformin, rapamycin, senolytics, probiotics. I do all those things, but I call them the usual suspects. They'll get us maybe a few good years, but not a half a century that I'm going for with my star shot. And we can wait and wait and wait for affordable innovations in some of the ones we see here that are under development, keyword affordable. And clinical evidence leads us, or me anyway, and I'm hoping to provide you with information to lead you to conclude what I've concluded, that the best, and this is the first of three, the best age reversal therapy we can do right now, it is available right now, is therapeutic plasma replacement. Now I'm going to get into some details of that. But that one is a bridge to developing the next one in my book, top three, advanced exosomes and other plasma-derived therapies. And under Bill Falloon's organization, he's funding several of these. One of them, you may know, Akshay's, and I was kind of honored to be instrumental in putting some things together and making some things happen for the next generation of Akshay's testing and development. Now, those two, remember there are three, are a bridge to what in my book is the ultimate that we can conceive right now. Yamanaka, specifically OSK gene therapy to reset the epigenome, cellular reprogramming. And we'll stay tuned to developments in others, and we'll help whenever we can, but time is limited, tick-tock. You know, gene therapy, mitochondrial, I want to hear the latest from Matrix. And after that, we shall see. It's a great, big, beautiful path out there. Look, I'm 74 years of chronological age. Now, I truly believe I'm in my prime, but tick-tock, like that famous movie line, my biological clock is ticking. I do not have the luxury of time. That's why I have to focus sharply, no messing around. Do you? Do you have time? I hope you have a lot more than me. Do you have a better plan? This is an open invitation. Prove me wrong. I can swap out any of my three or all three. I'll jump to a better plan. I'll help you, no charge. I don't think you do. You'll have to convince me because I've spent some years working on these. Now, I am leading the plasma project with the help, again, of some friends, and also a part of the Falloon BioFuture team's exosomes and Yamanaka OSK projects. The plasma project is ready here and now for humans. The other two will be next level humanely tested on African green monkeys at Colony off of St. Kitts. I recently moved most of the time to Florida to be a part of this. St. Kitts is off of Florida. We're developing relationships and have relationships actually in the Bahamas where they can do some things there that are more difficult here in the US. There was some new legislation. We also are developing relationships with doctors and clinics throughout the world. Now, therapeutic plasma replacement. I know a lot of you are sophisticated, but I'll take it to square one. That's when plasma, the plasma component of blood, is removed from someone such as myself and replaced with the plasma, blood plasma, from someone roughly in their early 20s. And here, this is a very important point. Research shows, and I can show you this, that this plasma donation has positive cognitive, athletic, and health benefits for the young plasma donor. There are variations to it. Therapeutic plasma exchange, out with the old, in with saline and albumin. A lot of people are doing that these days. And then there's just a straight infusion with nothing removed. Plasma donation is safe. I could show you the document, but in the interest of time, tick-tock. Most of you have probably seen this, but just in case you haven't, an old mouse and a young mouse were sewn together. Their circulatory systems commingled. The old mouse got younger, the young mouse got older biologically. And there's the study reference on the bottom. Same principle applies to humans. There's a little Da Vinci for you. The donor's blood is highly tested for pathogens, and the folks in Texas have a way that they're doing it. My way is a little different, and we're going to have a much smaller group, much more inclusive group, and also very sharp attention to things like the APOE4 double allele, which is kind of a big problem, a predisposition for Alzheimer's and other cognitive decline. Minimal side effects are reported in therapeutic plasma replacement, and compare that with the maximal. And anyone who wants to talk about that doesn't believe that the side effects are minimal, well, we'll have a conversation. But I'll move on. Plasma is natural. It's like 3.5 billion years in development where it's not cooked up in a lab. Okay, about 2.5 minutes left. For me, the TPE, old out, saline, and albumin in produced the best objectively measured and subjective results of any therapy I've ever had. And I've been doing this, I've had a lot. It was even better than the umbilical cord plasma infusions that I've had. And my anticipation based upon the evidence, and I'm going to rip through some evidence pretty quick, is that the TPR will be even better. Now, here's another take-home point. Please remember this full range of balanced and complementary components. And I think Ron John is going to like this concept. I believe he will. Thousands of them in plasma from young people would be far superior and effective than just one or two or several combinations because they affect so many systems in our older bodies. Plasma is the liquid part of blood. Here's another high-level take-home point, very important. It contains exosomes, cytokines, growth factors, metabolites, all the things you see here. If you look at the video, you can stop it here, but we got to move on. Now, I figured it was time for a pretty picture. Okay, it's like a rainbow, a full spectrum. Even throw in a flying unicorn, what the heck. And the hallmarks, the new hallmarks, there's now a lot more of them. This one talks about exosomes in some of the components. This one names some of the cytokines, growth factors, mitochondria, miRNAs, hormones, albumin. I got to rip through. Again, so important, I'll say it again, balanced, complementary, thousands of them. They affect multiple systems. Big evidence that these therapies help with dementia, Alzheimer's. Aging is very complex network, and this therapy affects multiple systems. All right, now the rubber's meeting the road. Here are some published scientific, 10 seconds left. Okay, published science. Look at them all, okay? I have a lot more for you. I have skin in the game, make the world a better place. You can't take it with you. See, Grim Reaper, leave it there. This guy tried, how's that working out for him? Helping me is the best thing you can do if you want to be biologically young again. If money's that important to you, think of how much more you could make if you just had more time. Come to my birthday party, 2049. Here's how you can reach me. I'm easy to find. Okay, sorry. I don't know how I went over, but
It's okay.
let's open it up some questions, but may I please ask the audience a question first? All right, look, this is, now I'll, in the interest of time, I'll skip that joke, but this is something different, something completely different, Monty Python thing. Many of you are investors here. It's something different than what you were expecting, but you know, those of you who have fire in your belly, where it hits you right here on a visceral level, where you love life, you just want to let it go as long as you want. Please just raise your hand. Let me know if that's something, yeah, passion. Okay, well, you know where to find me. Thanks. Oh, wait.
Going in.
Yeah.
Yeah. So thank you for the presentation. So if you have a question, just raise your hand. I'll pass the mic for you. And also so the people on the Zoom will be hearing those.
So how frequently should we do the transfusions?
Well, it depends on you, and it depends on which variation. And in my vision, it is a highly personalized thing for a small group of people where, you know, you don't know until you evaluate it. But I'm sound like I'm backpedaling here because I don't know you. I don't know what your physician. For me, you want to know why I'm doing this? I want to unlimited once a week is what I'm going to try and watch the biomarkers. You know, you can't manage what you don't measure. And if there, for some strange reason, are any negative effects, I get too energetic and, my wife starts to complain, hey, honey, back off a little, then I'll back off on it.
Isn't once a week a bit impractical because you have to spend half an hour going to, et cetera, donating it, getting it back, you know?
Well, there's so many things we haven't covered here, but this is where I would let's live next door to the Plasma Donation Center. And something I didn't mention, this is all under an investigational review board approval. And so everything is regulatory compliant. But you can go to Texas right now and find out for yourself. So I'm sorry if that wasn't a satisfying answer, but depends on things and your doctor's approval.
So I'm curious, if you do it once a week, you assume that your biological age will be reduced, right?
Well,
what do you assume it will be frozen in time, or?
I'm not going to assume anything. I'm going to measure and then take action based upon the biomarkers. And wow, it's another 1,500-minute discussion about biomarkers and objective measures, but I look at multiple kinds. And we can, if you join me on one of these online meetings, we'll talk about all that.
Hello, how much time do you wait from the moment of the transfusion until you measure the biomarkers, just to know that you are not measuring the biomarkers of the other person?
I'm not quite sure I understand that question. And there's something that I would have to explain more to answer it best. But I would say, again, what you and your doctor approve of, and depending on your budget and the types of biomarkers that are indicated in the study and that you choose to do on your own. I mean, if you go in a clinical study, I don't think anything would prevent you from doing biomarkers at any interval you wanted to do. But now I'm going to give you a straight answer. I would say wait a week or two after, and then compare them with the baseline. And this presentation involves AI. Part of what we're going to do will use AI to evaluate biomarkers as well as just look at the data, common sense. Go ahead.
Just quickly, so I forget the name of the book of Oliver Sacks about iDopa. Was it Awakenings? Was that the name of it? Yeah. Yeah, about the patients that were frozen for decades, and then iDOPA came up and they got back into movement. So do you expect that kind of, regeneration in terms of movement and activity, and or do you have no idea right now?
Well, I call it a star shot. It's the greatest challenge and adventure ever. And like you saw at the start of my presentation, I'm going for age 26. That's my number, physiologically, functionally, whatever. And it isn't just the first thing, the plasma. The plasma is something we can do right now. And that's a stepping stone to the other two. And then after that, we'll see what comes after that. So did that answer your question?
I think so.
Yeah. Okay. I thought you might be talking about cryonics or something first. So I'm not in that club. I guess I should be, but for me, no plan B, do or die. No pressure.
You actually look for patients or volunteers to sign up for this,
Oh, well, two answers to that. One, they are doing it now in Texas. You could fly to Texas and have these treatments. But for my thing, I have a backlog of individuals, but it's taken, I intended to have it going and up and running a couple months ago, but it's complicated.
In Texas, how many patients are we looking at? How many individuals are you looking at?
That have ever been done? Well, I've been advised that 1,400 liters of plasma have been delivered to patient subjects, many of them, if not most, for age reversal, some of them for medical conditions. It's HIPAA stuff. I'm not privy to that, but at the average of 2 liters per treatment. And if anyone wants to go to Texas, I know all those people. I've met with them, interviewed them personally. I'll just suggest that talk to me first, and I'll explain, full disclosure, why. And a second reason aside for me, why I make that suggestion.
What's the cost of this procedure, Johnny?
Oh, for me, I'm still working out the cost. My intention has been to make it affordable and a lot less expensive, but it's taken a different course. The cost for in Texas, it's $5,000 per liter of plasma, and I'm going to make this answer as brief as possible, but I have to give you some background. I've been in Spectrum Plasma over there. They have a lot of overhead, a lot of regulations, number of people, so 5,000, and a doctor per liter, yeah. You can take 1 or 2 or 3. It's like, the old Sears thing, good, better, best. 3 is recommended, but 2 would have a very good effect. But then there's the doctor's professional fee, and that starts at 5,000 and goes up depending on whether you want like a concierge service, black car meeting you at the airport, everything.
Okay, thank you, Johnny. Very interesting talk. Yeah. So can some people do me a favor, because we have more people coming in? If you say a CSB space, you can move along so more people can be seated. And also, you can see we have passed out those flyers. There's a QR code. If you're interested in any of the companies today, you can scan the QR code, go to our website, and express your interest in the companies. And next company, we're going to have Matrix Bio.
Okay. Hi, everybody. Thank you, Ranjan, for the invitation. My name is Joel Nayor. I'm a physician. I have been doing drug development for the last probably 20 years, so the majority of my career. 2 years ago, I went back to school, went back to Stanford and met Ranjan there in one of his classes. He introduced me to Matrix, and I was really taken by what this company is doing. And I'm here to present on their behalf and on behalf of Tom, who's their CEO, who couldn't be here. So extending lifespan, health span, really boldly going where no man has gone before. That's a high threshold. And Tom managed to get around and get interested, a really good team, not only people like William Shatner, who may have been there already and has a high interest in what Tom is doing, but also reputable scientists, as you can see, a couple of them here, and people that are very well known in their domain. And in addition to that, the company also managed to attract and interest volunteers who are keen to support the company and even participate in clinical trials once they're established. So what is this company really about? The mitochondria are also known as the powerhouse of the cells. They're really the primary function of the mitochondria is to produce energy. They're very abundant. They're in all the cells of our body, and they have their own DNA. So they're like an organ within an organ. And if you think about their function, you can also imagine how they're related to aging. So mitochondria divide just like cells, and they are exposed to stress and damage. And over time, just like cells, the mitochondria age. And their aging is more critical in organs that are very high energy intensive. So think about the retina of the eye or the heart muscles that pumps and works all the time. And also, whenever an organ is stressed and needs a lot of energy, like, for example, the immune system, when it has to combat systemic infection, under those conditions, if the mitochondria is compromised, one will notice that in decline function. So really, the premise is that mitochondria aging is foundational to the aging process in general. And this is well exemplified by this concept that actually Matrix brought forward, the mitoclock. So what this is about mapping the DNA of the mitochondria and seeing where there are mutations. And in this graphic, the mutations are represented by those blue dots. And you can see that in this individual that is 93 years old, there are a lot of those dots. And you can assign a damage score to that. And in this case, one could see it's 25%. So 25% damage. Now, when you go to another individual in the same family that is just 62 years old or younger, the damage score is lower, 11% less of those blue dots. And so forth, for a 32 years individual, it's 7%. So a mitoclock that helps you see sort of similar to other clocks where you are in the aging process. And you can chart that. In this case, those mitochondria were derived from the urine, so they're probably kidney mitochondria, or the majority of them. And you can see that decline in terms of their vitality with age. And you can even conceptualize that at a certain age where most of us will experience symptoms, that's kind of a critical threshold. So what if you could boost the mitochondria within a certain tissue or in the body, generally speaking, and further push that aging process or delay it further? So that's a concept that Matrix is thinking about in the way they're conducting their research. And another thing that is sort of important to realize is that, and that wasn't, by the way, known when I went to medical school only later, because this is a fairly young science, is that mitochondria are actually excreted by cells, and especially stem cells, and they form extracellular vesicles. And those vesicles go into the bloodstream, for example. So you could think about the bloodstream and the circulation as a way to transfer mitochondria and to replenish or augment its density and replenish the tissues with younger mitochondria and help deliver it throughout the body. So another concept that Matrix is developing is the mitelet. The mitelet is related to a mitochondria that sits within a platelet. The platelets in our blood are very short-lived. It's a matter of days, like 10 days, 7 to 10 days. And if you think about it, it would be a waste not to use those or reuse those mitochondria. So when platelets are activated or die, their mitochondria are released into the bloodstream in the form of mitelets. And Matrix is using that and in fact are harvesting mitelets from platelets for the purpose of their experiments. And this is another concept that is related to what we heard by the previous speaker, in the sense that this is a bioreactor treatment process. So what are the hurdles that one faces, or the challenges that we have when we think about mitochondrial treatments or augmentation? If we want to treat the whole body, we need a lot of mitochondria. So we need to scale up the mitochondria production, and we can borrow from stem cells research, where you'd use a bioreactor to grow the cells, and in this case, the cells have mitochondria in them, and you'd grow it, and then you'd harvest the mitochondria. There would be young mitochondria, and furthermore, you can even coat the mitochondria with special molecules that would help the mitochondria reach the target tissues that one would like to reach or to enhance the specificity. So if you do a transfusion of mitochondria, you want those mitochondria to reach maybe certain organs, depending on what you're trying to achieve, more so than other organs. And then you do it in a transfusion center, and this is how you'd go about it. So this is one of the things that Matrix is thinking about. And I'll give you a couple of examples now of other things that Matrix are doing and looking into. So I mentioned earlier, I talked about sepsis. Sepsis is a systemic infection. It's in the blood as opposed to just being in one organ, and it's very taxing on the immune system. So can you do anything to boost that? And we know that actually the older you are, the higher the likelihood that unfortunately you would die from sepsis, or the consequences of sepsis will be devastating. So in this experiment, which was done in mice, sepsis was induced, and these are old mice that were transfused with young mitochondria. And you can see it was repeated twice that the the researchers were able to extend the life of those mice and to help them combat sepsis. The eye is an excellent organ to do targeted treatments. And I'm biased because I'm an ophthalmologist, but you know that, for example, gene therapy made a lot of progress in ocular diseases, and that's because you can access the eye readily, externally, and you can deliver the drug to where you want. And importantly, you don't need a lot of quantity. You don't need a high volume in order to treat. So one of the things that Matrix had looked into, and by the way, there are a lot of conditions in the eye or tissues that are very energy demanding, like the retina, like the corneal endothelium, etc. I don't have a lot of time to get into that, but so Matrix used tagged or fluorescent mitochondria. They injected them into the eye, and they were able to show that the mitochondria are being taken, internalized by the cells of the eye. And again, that's a concept that maybe they may be able to use therapeutically. So is mitochondria the all it be? It probably not, but it can certainly help, and it can be used together with other modalities. Matrix, and I personally believe it's an important and could be very effective to achieve some of the things that we're trying to achieve. So Matrix is always looking for people to support and volunteers, just like we heard in the previous talk, people that are interested, but more so, it needs funding to continue to be able to do what it's doing and to progress. So I'm actually through. So this is Tom, and he's the CEO of Matrix, and I'm happy to put you in touch with it or with him or answer any questions that I can. So thank you very much.
Questions?
Yeah. Maybe I can speak. Do you need a matching donor for a mitochondria?
Yeah, that's an excellent question. So so far, there is not a lot of evidence that matching is important, but it could be. So we've not, or Matrix has not yet done human experiments, but it is an important question in the field as to whether you'd use your own mitochondria, you'd harvest your own and grow it, or you could use donor mitochondria, and to what extent you need to match. So, yeah.
Your own animal model, right?
Yeah. In the animal, no, you didn't do.
You don't do it? Okay.
Yeah.
Thank you.
Yeah.
Thank you. Thank you for the presentation. About the platelets donation, is there any positive effect for donors? I try to donate platelets every 3 months.
Yeah.
Is there like any regenerative effect of mitochondria on this donation? If I
On
got
the
it right?
donor.
From the donor, yeah.
I'm not, so you mean to the donor? Is there a positive effect to the?
Yeah. Donate platelets.
Right.
The body, kind of.
Oh, so.
Is there any mitochondria positive effect?
For the donor, I'm not aware, yeah. Okay. Yes.
When will the first bioreactor be finished?
That I think I'm trying to think about how Tom will answer that. That depends how much money he's able to raise, probably.
Let us have this conversation, right? So you say you are given plenty of money. There is no limit to
Yeah,
money.
yeah.
How long should I wait to get this?
So I estimate that with unlimited resources, this should not take more than 5 years and probably less in terms of the ability to make this real. Yeah.
Awesome presentation. I'm from a CS background, so I really enjoyed your comparison to the hardware operating system. I was just curious whether you've done any experiments in microgravity, for example, like outer space, because I saw some NASA articles about mitochondria.
Yeah, I know that NASA is interested actually in mitochondrial science, given all the side effects that astronauts experience and when they come back to Earth. I'm not sure that they've done experiments in microgravity, but
I'm just saying I know
interested.
The intention's out there. Because I've done like some BizNev too, so I was just I don't know if that's like a good grant that NASA might pay you for. I don't know.
Thank you. They're definitely interested in mitochondrial science. Yeah.
Awesome. Thank you.
Hi, please don't get mad at my question, but trying to figure out how do you support a 60 million valuation? So like how far you are from like revenues and I'm just trying to understand that story. Sorry.
Yeah, so I'm not the best person to answer that. I think that's a question that you need to discuss with Tom, who's the CEO of the company, and how he came up with the number. But the reality is that this is a moonshot, and I think if he's successful, if Matrix is successful, there's unlimited potential, and there is room for more than one company, by the way. And there are multiple companies that are trying to do this. Yeah.
Yeah, thank you so much for the great presentation. Yeah, I just want to clarify, do you expect any adverse drug reactions, like side effects, after using such technology in human?
Yeah, so there could potentially be side effects, but so far with the animals, they haven't seen something that would cause them to halt and not proceed. But yeah, conceivably there could be. That's why you run the trials. Yeah.
Thanks.
Lots of questions.
Thank you. Do you know how far away you are from a clinical trial starting?
Yeah, so to the question or questions that were raised, I think this would depend on how much funding the company has, but depending on the regulatory pathway that will be selected, I think that it is a reality that 5 years or less, one could be in humans.
Volunteers.
Yeah, so like I said, in terms of lots of people are interested, especially if it's safe. And Tom will tell you that it's not a surprise. The older the individuals, the more likely they are to participate. These concepts are not, it is very likely, I don't know if I said it during the presentation, but when you do a plasma transfusion or a blood transfusion, you are actually transfusing also mitochondria. So this would just be an enhancement of this process in concentrated mitochondria. Could there be side effects to the question that you asked? I mean, maybe, but yeah, so I think that that's one of the things that gives me comfort that eventually it will be a safe thing to do. Yeah.
It seems like there's a little bit of controversy as to how much of the mitochondria actually gets in the cells.
Yeah.
And I don't know if you have any definitive results on how fast and how many trillions you got to put into a human body to make a difference.
Yeah, I touched on this point when I talked about mitochondrial coating. I think that is one of the challenges that the field faces in terms of internalization and the rate of internalization. And there are many ways to approach it. In fact, just this morning, I had a conversation with someone in Stanford that is thinking, has a provisional patent about a way to do that. So the coating of or the engineering of the mitochondria is important not only for the rate but also for specificity. If you want to target one organ compared to another.
Have you found that there are any particular organs that would probably be more effective to have this treatment? As you said, there were particular organs that are energy intensive. Have you?
Yeah. So I think that those organs that are energy intensive are good organs to target. So people have already been thinking about the heart. Sepsis is a good model, like because of it's a transient energy intensive state, but it is an energy intensive state. I personally am thinking a lot about the cornea of the eye and especially the corneal endothelium. People are thinking about the retina. So any tissue in the body that is sort of overdrive, especially tissues that can easily be accessed and tissues that do not require a huge quantity of mitochondria. Another advantage of the eye, again, I'm a great advocate of the eye, is that it's an immune privileged site. So to the question that was raised earlier about immune reaction, it reduces the likelihood of the body reacting to the mitochondria that are as a foreign. Yeah.
General view on all the supplements out there marketing towards mitochondria and urolithin A and everything that's going on out there. It's really you got to stay away from the snake oil salesman here. We're trying to find stuff that works with some data supported, but just wanted to hear your views on that.
Yeah, I can't claim that I've looked carefully into that, so I'm sorry.
Tom said this is not treatment won't be enough.
Not enough. Yeah. Makes sense.
Okay, we can take one more question. Okay,
So is the mitochondria differs by, depending on the location of the yeah, it's very specific to organ, and my mitochondria around this eye cells versus my mitochondria around are they exactly? In terms of function, maybe the same, right?
Yeah.
In terms of their whatever construction, is the same exactly?
Yeah, they're fairly similar. So they have the same
mitochondria for
I think to the extent that the science is developed right now, it's not perceived that, or there's no evidence that they're highly differentiated depending on the organ. Yeah. Okay. Thank you.
Thank you for Matrix. And next one will be Melio.
Thank you. So I'm glad that Matrix already introduced sepsis to the audience. So sepsis is the immune response to severe infections, and severe infections cause more deaths today than opioid overdose, prostate, and breast cancer combined. And last year, new data came out where for the first time in 20 years, we saw an increase in infant mortality in the US. And bloodstream infections is a top contributor for that. And in spite of all of this, diagnosis by standard of care still takes days. And as a result, there is delay in targeted treatment. And with every passing hour, you increase the chances of morbidity and mortality. And you also end up giving all of these patients empirically antibiotics, which can have a tremendous impact on their health, especially if there are newborn babies or infants. You just bombard their microbiome and you set them up for a lifetime of asthma, allergies, and GI issues. And so Melio is changing that. I am, by the way, sorry, I forgot to introduce myself. I am Mridhu Sinha. I am the co-founder. I'm Dr. Mridhu Sinha. I'm the co-founder and CEO of Melio. And Melio is developing a platform to identify all infection-causing microbes in a single test in 3 hours instead of days, which the standard of care takes today. And if you look at the problem, what's the space look like today? The holy grail for infectious disease diagnostics for something like bloodstream infections, you need to have two attributes. You need to be fast, and you also need to have the coverage so that you can detect all common microbes in a single test. But unfortunately, you have tests that are fast, but they can only detect a few pathogens, and they're also expensive. Or on the flip side, you have tests that can detect a lot of pathogens, but they are slow. Either they're based on standard of care, which can take up to 3 days, or they're based on sequencing. You have to send it out to an external lab. It's extremely complicated workflow and very computation and resource intensive. And so Melio is changing that, delivering on both speed and coverage of pathogens, so you can have a comprehensive test that can impact patient care. And so what we are delivering is a platform where user can load blood, run the test and walk away, and you can get actionable pathogen report where you can identify 98% of the most common pathogens, but you can also detect other rare microbes. There's a software component to our platform which makes our molecular diagnostics universal. So even if I encounter a pathogen that we haven't seen before, I can flag and say, hey, you know what? It's not something that I've seen before, but it's definitely something new. And our business model is a classic razor blade model. The test cost is 150, but it has 90% margin. And we are going to sell the instrument either at cost or as part of reagent rental, and we make money by selling consumables. And so what we're doing is advancing every parameter that's needed to be successful in the clinical lab: automated direct blood handling, much faster than conventional culture, much cheaper than sequencing methods, and a universal assay chemistry that can detect all common pathogens in a single test. And you can expand by software. So you bring molecular testing into this era where you can detect more and more microbes as you encounter them with just algorithm updates. And we can talk the talk, but we can also walk the walk. We have published heavily with this. We, in fact, this year and last year published multiple studies where we have shown feasibility with real patient samples for detection of both bacterial and fungal pathogens with as good accuracy as the standard of care, but we detected it within hours instead of days. And so the reason we are able to do this is because we are reinventing the workflow of how diagnostics work. And this is where I'm trained as an engineer. And so I came at this problem. I'm like, what, there are microbes, there are microscopic things that you can look at them, they're there, but you can't detect them. And so it blew my mind. And my first thing that I did during my PhD was I wrote a review paper on trying to understand the problem. And my MD clinical mentor actually told me, Mridu, who's going to read this? And that became the 18th most cited paper in clinical microbiology journals, which is an Impact Factor 22 journal, which shows you the impact and the need in the community to understand this problem and to solve this problem. And so we are doing multiple things differently, and we have an inventive and a new workflow, which is backed by 14 issued patents. And so first, instead of doing DNA extraction upfront, which is how everyone works, we hold on to whole microbial cells, and we interrogate whole microbial cells individually by something called their DNA melting curve. So what is DNA melting? Much like you don't have to read a sentence by reading every word letter by letter, we can actually sequence the DNA without having to sequence the A's and T's and G's and C's. And so we use something called DNA melting, where you heat the DNA and you watch how the DNA breaks or falls apart. So DNA is a double helical, double-stranded structure. You heat it and it begins to break apart, and you monitor how it's falling apart by a fluorescent dye. And that pattern is specific to the DNA of the microbe, and we use that within a machine learning framework to identify the species itself. And so what this can do is push molecular testing in a realm where you can not only detect what's known, but you can also monitor for novel emerging threats. And this is not just a dream. When we did our clinical testing, we actually encountered fungal pathogens which were not detected by standard of care. And we found something. We saw these novel signatures and we flagged it, and they turned out to be relevant pathogens. We had another example where we get isolates from clinical labs, and we got a clinical lab isolate and said, this is supposed to be pneumonia. We're like, wait, no, this is not pneumonia. It's definitely something. But it's a new pattern. And turns out it was an opportunistic pathogen that sticks to pneumonia called E. formaceae. So that's the power of the platform. And if you take a step back and move out of the technology into, what's the market and how can our investors make money? This is a pretty big market. And we are starting by addressing the acute care setting, and especially in high impact market with neonatal sepsis. So diagnosing neonatal sepsis is a top of the mind issue for every neonatologist today. And because we don't have diagnostics, for every baby that needs an antibiotic, 150 babies are given antibiotic. And what does is you just alter their gut microbiome. And now the clinical community, so this is a practice that started maybe 20 years ago, and you now see the effects of this in babies that have grown, and on a population level, how it can affect their gut microbiome. There's 50% higher chances of that baby having a life-threatening allergy or asthma. And so neonatologists recognize this now, and they are trying to bring in policies and procedures to reduce antibiotic use. And antibiotic use is becoming a quality care metric in the NICUs. And so we have committed neonatologists who work with us, and we want to start there in the NICU, but quickly scale up to the entire adult population, because if it works for baby blood, it will work for adult blood. Blood is blood, and the microbes are the same. And the lab director today does not differentiate between how they test baby blood and adult blood. And so we can quickly expand to a larger market for infectious disease. And our business is fueled by consumables. So each single instrument install can actually generate revenues of $220,000, and that's how you can grow. And in terms of where we are as a company, we in the past we have done about 7.5 million investor funding. We started right at the time of COVID, and I was a solo founder, and I'm thankful to R42 and the rest of the investor community that they believed in us and our vision, and we only had like our belief that we can do this. And we recently closed our first equity round, which is 5 million, and we were able to 1.5x it with dilutive funding as well. So we have non-dilutive funding. Thank you, Ranjan, for being my partner here. And so we have shown that this technology works with pilot clinical studies. We have a good patent portfolio. We have committed KOLs. We have 9 partnerships with major hospital systems: El Camino Hospital, UCSD, Rady Children's Hospital, Corwell Health, University of Utah, and a few more. And we've also spoken to the FDA. We have an idea of our regulatory strategy. We've gotten positive feedback. And now with this money that we have raised on the non-dilutive funding, we are delivering the integrated clinical research ready prototype, about 3.5 million. And yeah. And so we anticipate we have the opportunity to actually get more non-dilutive funding. After this, there are some milestones. If we meet those milestones, we can get an additional up to 8 million. But we'll either do that or we'll raise our next round, which will take us about 10 million in 2 years to get to the final commercialization and launch. And we believe we can do this because we have an awesome team. Amongst the team, we are 18 people, and amongst the team, we have had about 12 successful exits, IPO acquisitions. There is about 120 patents in the industry. They're all industry seasoned professionals, and we have 3 things in common: perpetual hope, confidence, and humility to learn, unlearn, and relearn. And again, I'm thankful for, I don't know where I am on time. Perfect. I'm perfect. Okay. And so, yeah, I'm thankful also for some of our clinical and scientific advisors who've been an integral part of the support system that we have around our team. And then, yeah, thank you so much for giving us the opportunity to come back and present. By the way, this came full circle for me this year because I have a 7-month-old daughter. And when during labor, I heard neonatal sepsis, like sepsis, because I had a long labor and I did not have any infection. But just because, anything can be an infection. If the baby is lethargic, if there is a brain injury, if there is prematurity, if there is a normal respiratory distress, they can all mimic infection. So it happens more often than you think. It's actually one of the most common drugs given in the NICU, antibiotics. And so I experienced it firsthand with my own daughter. Questions, sorry.
Questions? Okay. So let's go.
Thanks for the presentation. Just a couple of questions. One is sequencing still at the core of your methodology in determining pathogens? That's one question. The other question is, when you do this analysis on antibiotic use in the NICU, how often do you feel targeted antibiotics will be beneficial in terms of application versus a broad antibiotic out?
Yeah, absolutely. So we don't sequence. That's the whole point of this. We can understand or read the sequence by their DNA melting profile. So this is what we get. These profiles are DNA melting curves for different sequences of DNA. So we're not sequencing, but looking at the sequence by using DNA melting curves, which is much more easier. Essentially, the instrument that you need a heating element to it and an optical element, which is pretty much any qPCR instrument. So we don't do sequencing. And to answer your second question, how often? So 99% of all the antibiotic use is absolutely unnecessary. And most babies will get started empirically when they get started empirically on a broad spectrum of antibiotics. And knowing whether or not they have an infection, you can A, start or decide to not start antibiotics, and B, you can tailor it to the right antibiotic. And it happens really often. So one of the example would be E. coli. It's becoming one of the most common causes of early onset sepsis when a baby is born. And empiric antibiotics, there's often a chance of resistance. They won't cover it. So you need to have targeted treatment and need to know the species to go in with the targeted treatment. Also, staph. If you get staph in, So there are plenty of examples where targeted treatment, you need to know the species to start the targeted treatment.
Congratulations on engineering such a great product. We are definitely going to be a customer of yours, so we'll meet you afterwards. This also works on viruses?
Yes. So since we were formed in COVID times, we actually showed that we can take an assay not knowing that coronavirus COVID-2 exists. And we did a universal virus for the family. And we were able to detect the new strain with a new fingerprint. So if there is SARS-CoV-3, we can use the same assay and detect SARS-CoV-3.
So the 97% also includes virus?
So the 97% we did was for bacteria and fungal. We haven't tested viruses. Viruses are not on our first MVP. We cared about bacteria and fungi, but we are doing a study for CMV virus, which is, again, really important for the neonatal scenario with the University of Utah.
Thank you.
My question was partially answered already, but just to clarify, if most infections are caused by E. coli or Candida or staph, do you get information on any resistance they have?
Yeah, so this we can detect the top few resistance markers. So we are targeting in our first panel the most common ones: ESBL, MEC, vancomycin A and B, and KPC, which will cover most of the common resistance that you see. And these melt curves can be for the species and also the resistance markers. Now, we cannot do all the resistance markers. That's not what we can do, but we can do the top most common ones.
Thanks. Just a follow-up question. How confident are you in the 510K pathway versus a de novo if this is a new methodology?
We are confident because there are product codes like T2 biosystems. They are direct from blood test, so their product codes apply to us. We've had informal conversations with FDA, and we feel pretty confident that it can be a 510K.
The technology to determine it is different, or is it similar? Is there, for example,
The technology is DNA detection based on amplification and melting. And T2 is also detection of nucleic acid. So the product code is detection of nucleic acid. And so, by the way, with FDA, it has happened in the past that even if the technology is slightly bit different, you can still have predicates, and they end up with a new class code that they generate. And even if it's de novo, it's not the end of the world, because
No, I've been through both.
Yes.
So, it's close to the end of the world, not quite. So it's just, you need a whole lot of different clinical data, and de novo is more challenging. Certainly is doable, but there's advantages of de novo as well. But just the question I have is there peer-reviewed publications on your methodology?
Yes.
Is it the same methodology?
yes, we have peer-reviewed publications on our methodology. And just to answer, by the way, T2 was a de novo when T2 came out with a study, even though they only detect 5 pathogens and it was not clinically actionable. And T2 had a clinical study where they did 2,500 patient samples. And because it's known that you can't having standard of care positive infections is rare, the clinical sensitivity was done with spiked samples. So we can do the same, where you can have clinical sensitivity with spiked samples, and for specificity, you do clinical studies, and we anticipate similar numbers, 2,500 total patients, and most of them are going to be negative. You'll probably have 50 positives.
Okay, we can take 2 more questions. All cool? All ready?
We would like to do that for our investors if the funding works out. Sometimes dilutive, or not sometimes, non-dilutive funding can also be slow. And so that's what we have to balance. We don't want to be slow. We want to work with urgency, and
certainly the economics, how much the machine costs, the usables, etc. Played out for.
yeah, so that's our install base in blue, and that's the revenue. So the machine will cost $15,000 around, and so you can give it at cost, or it can be part of reagent rental, and you make the money by selling the consumable. We have done a lot of medical advisory board. We have a formal medical advisory board also, and we have done about 120 customer interviews, and we believe that $150 would be a good price point for us. If you're being very pessimistic, it's $80, and these are conservatively projected numbers with that. And so COGS is $10, and that's the cost.
So at 637 at the end, what's the EBIT? 637 million in 2031. What's the EBITDA?
My goodness, I'm not in the fundraising
Or
mode.
just I've got nothing to do with fundraising. Nothing to do with fundraising.
So I have forgotten these numbers. I apologize. I should know.
The profit, in other words.
Yeah. So I think we break even somewhere around year 4, and then after that it's profit. There you go. Thank you. Thank you. Thank you. Thank you. Thank you.
Okay.
See, the scientist in me wants to know everything before I answer.
Just one quick question for you. So as you now enter the phase when you're going to be selling this stuff, you have the person on the team who's going to be driving those sales and those deals?
Absolutely. So we are still about 6-8 months away from ramping up commercial. But Claude here was the GM of GE Healthcare, and he was the SVP at Thermo. And we have a lot of people like that in our network who come purely from marketing and sales background. And so we are keeping our advisors close and making sure, so all of these pro forma that we developed, of course, we taking inputs from the advisors and keeping this network warm. So when we are ready in 6-8 months, then we can accelerate the commercialization efforts. But right now it's more of a technical operations team.
I have a stupid leg question. So it seems interesting that you're separating each cell and taking a look at them. I don't know anything about the melting, but is it possible to just do video processing on the cells to be able to tell what they are?
So if you just look at the image, it's a lot more complicated. If you just do image, you need a lot more magnification. A lot of the closely related species have similar morphologies. So there are some imaging them without just the optics, without any dye or without any other aids is difficult. If you do dyes or if you do some other aids to enhance imaging, then you can't have universal chemistries. to do that. So there's a company called Superbio that's doing that, but they've done a lot of work with viruses, not so much with bacteria. So yeah.
Okay, okay, we have to move to the next. Thank you a lot for Melio. The next one will be Cordance Medical.
Thank you. Really appreciate this opportunity to talk to you. My name is Bhaskar. I'm the founder of this company. My background, I'm a biomedical device engineer. If any of you have had a ultrasound exam, it's quite possible that I've had something to do with this because I've been designing ultrasound systems for about 20 years now. So this company, we are developing a ultrasound device to enable precision medicine for the brain. So let me spend a couple of minutes on what precision medicine is. This is a sophisticated crowd, but let me talk a little bit about that and tell you why it's not possible to do precision medicine in the brain today. Precision medicine, there are two components. There's the sampling of tissue, and then based on that sampling, figuring out what the right medicine is, number one. So that's the precision medicine concept. In the brain, there are many reasons why we cannot do this. First and foremost, there's a blood-brain barrier, which is an anatomical structure which doesn't exchange fluids from the blood to the tissue. And if you think about the lung as another organ which is privileged, we cannot do biopsy on the lung. So what do? We do liquid biopsy of the lung, which the lung sheds tumor cells into the blood, and then we can sample the blood non-invasively. That's the concept that we're trying to bring to the brain. So then we are going to be doing non-invasive liquid biopsy of the brain to understand the disease status of the brain, and then based on that, to be able to figure out what drugs to be able to get into the brain. And then the same blood-brain barrier, which prevents that exchange between blood and tissue, is also the reason why we cannot treat brain diseases. So with focused ultrasound, we now can open a two-way street. We can diagnose the brain state, the disease state, and then we can deliver drugs to that location very accurately. Let me tell you how. But then before I do that, we do have a breakthrough device designation from the FDA, which is conferred on devices which are innovative and first in terms of going to the FDA and getting it through the regulatory process. We have a phenomenal team backing up this company. I founded this company. We have a great team in Mountain View. Many of these gentlemen on the right-hand side are and ladies are ultrasound engineers. We have a great team of clinical advisors from across the nation, from Duke, from UNC, from Stanford. We have phenomenal people who are advising us on the liquid biopsy aspect. And then we have Ranjan and a great bunch of investors who have believed in this company. I started this company with $0 and just an idea in my head, and got bootstrapped this company, got a couple of National Science Foundation awards, non-dilutive funding, and continued to get awards from NIH and NSF for the last several years. So the blood-brain barrier. The brain has 400 miles of vasculature in the brain, and it's a very privileged organ, the brain is. These vessels that make up the blood vessel, the cells that make up the blood vessels are tightly linked to each other. And that is the reason why it's very difficult to give a drug, for example, through the IV. It can go into the brain, ironically, those drugs, but cannot get from the blood to the tissue because of this tightly interlinked junctions that form the blood vessels. Similarly, when in the lung, when you have cancer, those tissues can shed into the blood, but because of the blood-brain barrier, it is difficult for these disease biomarkers to go into the blood. If we could do that, we can do non-invasive biopsy of the brain with our device and then sample the blood, then you can figure out what disease this person has. With focused ultrasound, with our device, we can very accurately open the blood-brain barrier with a very short procedure. It's a non-invasive procedure, and that's the key to our device. It's a non-invasive, applying ultrasound to the brain, opening the blood-brain barrier, temporarily for a period of about 90 minutes. In that period, we can either deliver a drug, but can also expect these disease biomarkers to come into the blood. We can sample the blood and figure out what the disease status is of the brain. How do we do that? We do this with focused ultrasound, and this is the product that we are making. It's a cap. It's a cap that knows what the internal anatomy is, and that's our intellectual property. We figured out how to place a cap without fixation frames, without screws, and then we figured out exactly where that cap is in relation to the internal anatomy. And then this cap has multiple ultrasound transducers. What that does is that we can focus ultrasound energy into the brain very accurately and open that blood-brain barrier for a period of about 90 minutes. The procedure itself, the ultrasound procedure itself, only takes 3 minutes. You can open the blood-brain barrier and you can have this exchange of drugs or the biomarkers. The machine itself that opens the blood-brain barrier will be a small portable device. We can take this machine to an infusion center. We can take this machine to a neurology clinic. Why is that important? Today, the focused ultrasound technology, this is not new. Opening the blood-brain barrier with focused ultrasound is not new. This was developed in 2000s. The part that is new is the fact that we can do this non-invasively and with a portable machine. Today, we have to have a MRI-guided system. We have to have this patient lying in an MRI tube for 4 hours. We have to have a craniotomy. This is not a scalable option. If you think about applying this for potentially for Alzheimer's, you cannot have 6 million people going in and out of MRI suites. That is the market that we are trying to address. We are focusing on brain cancers first and expand from brain cancers to beyond. So it's a small system. The best way to describe this is my advisor from Duke. She said, look, you are designing a system where you can go to a patient. The patient doesn't have to come to you. If we think about that for a minute, cancer patients are extraordinarily tired. They're weak. This is why we had the opportunity to go and service this large opportunity. Most importantly, about 80% of the care actually happens in community clinics. We can install this in a community clinic and have the opportunity for these patients to have diagnosis of the brain and drug delivery to the brain. Coming back to the science. Look, the science has been around for 20 years, and the machines that have been used to open the blood-brain barrier are, like I said, invasive, large, expensive. So the main thing I want to point out here is that the science of opening the blood-brain barrier with focused ultrasound, that has been really well established. We are not trying to develop new science. So the science risk is quite low. Our job is to make it implementation that is efficient. That's what we do. Long way of saying the safety of this technique has been really well established. Currently, there are about 300 to 400 patients that have had this procedure, and there's been hardly any side effect at all from the ultrasound portion. The side effects have mostly been through, you have screws in your skull, craniotomy. Those are the side effects. It's not because of the ultrasound deposition. So we can use all the science data as completely applicable to us because we are not inventing a new science. Let me go to the development plan. So the idea is to have this cap with a portable machine. But if any of you guys have developed devices, you know that the first time you make this device, it is not going to work. It'll be heavy, it'll be buggy, it'll be blah, blah, blah. So we didn't want to do that. I didn't want to do that. These devices, in an engineering lab could cost about $500,000 to make. I didn't have that money. So what we did do is that we designed a portion of that cap, a small portion of the cap, which has all the relevant parameters of the cap, and we can then place that on a module. We can then take the system, go through clinical studies, submit the data to the FDA, and have that data be available for the cap-like version. So the reason we know this will work is because we've already talked to the FDA because of our breakthrough designation status, and they have accepted this way of going from a module-like device to a cap-like device. We've done 18 large animals today, sheep, dog, and pigs. And we've got excellent results in terms of safe opening of the BBB. I will tell you that doing dogs is the hardest thing you can ever do. They're beautiful, they're cute, and if any of you have pets, it's just difficult to do these procedures on dog. We've moved away from dogs. We do sheep and pigs now, which is a little bit easier for me to handle. So anyway, so that's that. Then in terms of the markets that we can address and the applications we can address, there's a sonobiopsy, which is a liquid biopsy of the brain. And within that, we can do brain tumors, Alzheimer's, depression, ASD. Think about that for a minute. We can diagnose these diseases non-invasively. We don't have to go through the skull because those procedures sometimes are very, very obviously invasive and infectious, and sometimes they can lead to death. But we can do that non-invasively now. After we do that, we can then deliver drugs to that patient, again, in the same sort of setting. Again, we can do this for brain tumors, Alzheimer's, Parkinson's. There's some phenomenal data that says that, look, if someone has breast cancer, there are drugs to treat the breast cancer. But if those same cancers go to the brain, it's a death sentence. What do? You have the drug that's so ironic. So with those drugs now, which cannot get through the blood-brain barrier, now we can open the blood-brain barrier very accurately, and then we can deliver those drugs to the brain. And there's initial data that demonstrates that these drugs are very effective in treating the brain cancers as well. So we're going to focus on brain tumors, on the liquid biopsy aspect first, get the FDA clearance, and then expand from there to the other applications here. I just want to point out that in terms of the drugs that we can get into the brain, there's a large variety of drugs that has been demonstrated to be able to get to the brain with the focused ultrasound procedure, all the way from regular chemotherapies, TMZ, which is temozolomide, which is prescribed for glioblastoma, to carboplatin, which is a commonly used chemotherapeutic, and then antibodies, gene therapy, liposomes, and stem cells. So anytime we talk about gene therapies, like we heard from the couple of speakers now, it cannot get to the brain, but with this device, you can do that. One of the most interesting things about this research is that we have now plenty of data, not with our system, but with the other contemporary systems, that we can deliver drugs to the brain. And you can see that the drug concentration in animals are 3 times, 5 times, 7 times than if you were not to do the ultrasound procedure. But even more exciting than that is that the same results in the animals have now been demonstrated on humans. And that's where the excitement really lies. Currently, these procedures are done in MRI suites with a craniotomy. We have the opportunity now to do it in a community clinic. That's what we're looking at. Many of you might have seen the 60 minutes piece. Again, this data was not from our device. It was from a competitive device. Aducanumab reduces the protein load in Alzheimer's patients. There's a lot of controversy whether this drug is actually effective or not in terms of actually treating the disease. However, many of these patients have felt good and are feeling good after having aducanumab. But about 10 to 15% of these patients actually have infections of the brain, inflammation of the brain. Now, if you reduce the systemic dose, those chances of inflammation goes away. With this device, we can reduce the systemic dose, yet have the same effectivity in the brain. And the 60 minutes piece was all about that. So since I have only 1 minute left, let me just talk a couple of minutes about the competition. We have 3 systems out there. These 3 systems are establishing the marketplace for us, establishing the science for us. More power to them. We're going to go take their science and make this small system, which is small and portable, non-invasive, and that's how we aim to compete. And the FDA has recognized us for this effort. Currently, we are in the preclinical stage. We've done 18 animals, like I said. We've demonstrated that we can open the blood-brain barrier very accurately and deposit drug at a very spatial location. So all the data is now behind us. We are now developing the human capable system. And then by the end of next year, depending on funding, we hope to be in human clinical studies. And lastly, we are currently have opened a $5 million round, 18 million pre, And for that, we already have 3.5 in the is already committed or will be staff committed. And with that money, we are going to be completing the device development and looking at the start of clinical studies with this money. Thank you.
Okay. Questions?
Thanks for the presentation. I was just going to ask you in terms of the opening of the blood-brain barrier, how do you anticipate or what's your safety on CSF leaks in the future? And how do you know 90 minutes is enough? And how do you know the cellular load into the bloodstream is sufficient to detect?
Yeah. So yeah, 3 questions there. So in terms of the BBB opening, we actually do not affect the CSF interchange at all. So it's just between the plasma in the blood vessels and the brain tissue. We don't affect the CSF at all. There's no effect on the CSF. In terms of the 90 minutes, that's based on data. So that's based on the data that was gathered with the little catheter device there. So they've done a craniotomy. They put these little transducers underneath the dura, and then they looked at the opening of the BBB, and it's coming out to be approximately 90 minutes half-life. In 24 hours, it's completely closed, and we measure that based on gadolinium leakage. So we do the gadolinium leakage in humans and also in animals, and we figure out how much leakage there is. Then 24 hours is completely closed, but the half-life is typically 90 minutes.
That's just the last question. Is there any therapeutic effect of focused ultrasound?
Oh, my
you know,
goodness.
from like ablating tissue, et cetera?
Yeah, okay. Many multiple answers to that question. So in terms of ablation, I just want to be very clear. We are low-powered ultrasound. We do not ablate. So our job is only to open the blood-brain barrier with low power. Ablation is a whole different ballgame. So it's low power. It's actually even less power than what current diagnostic ultrasounds use for imaging the heart, the kidney, and the lung, that sort of thing. And in terms of the therapeutic effects of the ultrasound alone, it's been demonstrated that just ultrasound alone in Alzheimer's patients can actually clear the amyloid as effectively as the aducanumab. So there are multiple therapeutic effects of ultrasound by itself.
Thank you. Excellent presentation. I'm interested in the application to not to neoplasms, but to Alzheimer and depression, etc. Maybe you can elaborate a bit. Are you also thinking about focused areas in the brain, or more of a
What a great question. Thank you. So ultrasound, let me just bring up this slide here. Ultrasound is just a phenomenal modality. Okay, so it's my life, right? So it's like these little circles that you see on the cap. They are ultrasound transducers. I can excite them individually. What does that mean? That means that I can form the beam anywhere I want. I can steer the beam anywhere I want. More importantly, I can defocus that beam. I can sonicate a large area. I can sonicate a small area. I have that completely under my control, depending on the diffraction limit, meaning that I can do a very small area. But to answer your question, it depends on the disease state. So glioblastomas, large tumors, about 3 centimeters sometimes. So we need a large focal area. On the other hand, brain mets could be as small as 3 millimeters, and we can focus our beam down to 3 millimeters. So it really depends on the disease state. And that's why we designed the cap like this, to be able to do the really small tumors and the really large tumors. Or in Alzheimer's, when you think about the early stage Alzheimer's, it's very focal. It's right here in the frontal, frontal portion. So what we've been told is that at that time, if you can affect the disease, you have a better chance of treating the disease. Late stage Alzheimer's is completely diffuse. And that's when you get the ability to be able to reduce the amyloid protein in the widespread area. So we built the system to be able to do both those bookends.
Great presentation, thank you. Is there any negative effect from multiple treatments with the ultrasound, like once every month or?
Yeah. So best way to answer that question is data. So with these existing contemporary devices right now, people have had 10, 15, 20 repeated openings. and there's been no side effect noted so far. Could there be? I don't know. But so far, there hasn't been any effect so far, even with 20-25 treatments. So in some ways, if you think about it, it is a injury, reversal mechanism. If you open the brain, you have to close it back again. So it's an immune system reaction. So far, we have not seen, negative reactions for the patients I talked about. Most importantly, let me say one other thing. When we think about opening the blood-brain barrier, anytime we get radiation in the brain, anytime we get surgery in the brain, you are opening the blood-brain barrier already. So there's sufficient evidence that actually has happened. It happens, and we have to be careful. But so far, there's no evidence.
So you said ultrasound by itself is useful. Should we just all have ultrasound if there's nothing wrong with us, just in case? Because as you know, early Alzheimer's is quite difficult to diagnose, difficult to find.
Yeah. If we can demonstrate that in large number of models, of course, we should do that. In fact, we should definitely start up a program to do just that. And in fact, there are programs existing that do just that. So I think in 6 months, 1 year time, there will be sufficient evidence to do just that. Yes. Yeah.
I just want to clarify about funding. You mentioned that you raised something from NSF
Yes.
and probably from SBIR. I'm not sure, but
Yeah.
what technology did you build using that funding? Can you just
Yeah. So actually the first funding I got was from National Science Foundation, NSF, and that was 2 phases. I got $250K, and then I got $1.5 million. So the first money was all about designing the cap, about doing the simulations, doing the hard lab work to demonstrate this proof of principle. So that was in the very early part of the company. And since then, I've got an NIH award now, which I can take this to a lab rat and demonstrate liquid biopsy on rats. So we've used the money for those purposes.
Have you published that?
Oh yeah,
journals?
Yeah, we've had several posters. We are publishing now 2 papers, one with UCSF and the other one with the Barrow Neurological Institute in Arizona, with some of our results. Yes.
Non-provisional patents.
I have 15 provisional patents. 5 of them have been issued, and then I've got 15 more going. So
congrats. Yeah, good to hear. Thanks.
Just curious, how are you doing the targeting?
Yeah, what a great question. Yeah, so the initial step in all of this is getting the MRI and the CT of the patient. And the physician will tell us where to open the blood-brain barrier, depending on the disease state. So we take the CT and the MR of the patient, and then we register those images to the facial anatomy of the patient. And that comes to about 2 millimeters of accuracy. And then from a clinical requirement standpoint, it's plenty because these tumors are sometimes large. So that's how we do it. So there's 2-step process. There's a physician component, and that's just like today's CyberKnife procedure. And then we register to the patient. And let me just finish up there because he talks about patent. The piece that is, I have to pat myself on the back for this. The piece that's so clever about this, we don't tie the patient down at all. So even if the patient sits on a chair and is moving around, we can follow the beam just like CyberKnife. And that's the key invention that made it all happen.
Okay, thank you for Cordance Medical. And the next one will be Turn.bio.
All right, so thank you so much, R42, Ron, John, and Anastasia, and the entire team, and Perkins Coie for having us. Turn.bio itself is a company that is taking the technologies to the next generation. This is a corporate overview. So our goal is to turn back time in age-related diseases. Now, Who here is familiar with epigenetic reprogramming? Just trying to get a little bit of a, great. So allow me to focus on my, my presentation. But ultimately, our mission is to extend and enhance the quality of our lifespans. Isn't it true that we're living longer, but not necessarily healthier? And how do we do this? Through cellular interventions that are focused on age-related diseases. We know that ultimately, and I'm not going to belabor the point, a healthier future is a future that is a profitable future. We all know the impending loom of age-related diseases and how it impacts the world economy, not just the US. For example, in the US, $4 trillion were spent in 2020 in healthcare. And that's not just because of the pandemic. If you think about it, the world hasn't been prepared ultimately for several decades to really address age-related diseases. And if you think about the pandemic itself, it was targeting individuals from certain ages, right? And they were at risk. So as we go through time and space, we start seeing that not only is this something that is going to be profitable, but it's something that must be done, must be addressed. I'm personally an economist by training, and if we don't address this issue, it's going to bankrupt the modern world as we know it. Just so everybody knows, my name is Sergio Ruiz, and I'm one of the co-founders. I'm currently the COO of the company. And what brought me into this space about 14 years ago was the fact that my grandmother suffered from Alzheimer's. So I'm Colombian. She lived in Colombia. And I was trying to understand, as an entrepreneur, why so much money was really being wasted in a theory that never went anywhere. And that just made me want to throw the proverbial grenade into the healthcare system and disrupt it in the most positive of ways. That's how I landed in longevity, aging, because it just made sense. If you go to the root cause of a lot of the problems, the root cause of 87% of all diseases, you were going to find solutions that were much more meaningful. And this is why Turn.bio, in my opinion, is very different from a conceptual approach to modern drug development and therapies. We're not focused on one endpoint, one disease, just one issue that is going bad. Because historically, traditional pharma has been doing that, and the side effects are terrible. In fact, the cultural understanding is modern pharma fixes one thing, but breaks the other. So how could we really approach what we call aging, or the atrophy that happens through time and space, from a global perspective? Well, Turn.bio has been created to address all that and all those other problems. I've already talked about the difference, the issue of having an aging population. But the way we do it is through cellular restoration. We actually do epigenetic reprogramming. The way I like to explain it, and again, I'm a business person, I'm a scientist, and not everybody's familiar with epigenetic reprogramming. But if you think of DNA as the code of life and compare it to a beautiful song, a classical masterpiece, the DNA is the code. The song is every single note that needs to be hit just right, as the composer intended, with the right pause, with the right, note, the sharp, the flat, the vibratos, etc. Then the way it's played is ultimately the epigenome, or what we like to call not the genome, but the epigenome. The code itself is what we are, but as we go through time and space, it's not read, it's not played the best way possible, because we age and eventually we develop several diseases, we develop several issues, we develop allergies and chronic diseases. So we have figured out a way to reset this epigenome, to really play the song in a way that it's meant to be played, the way that your body knew how to do it at its prime in your youth. And we do this through a cellular reset. So when we have a damaged epigenome, as you know, the cell divides, the cell ages as well. You start creating some aberrations and mutations in the way the cell just lives and goes through time and space. So through targeted transcription factors, we give the cell a set of orders. Through mRNA, we tell the cell to do a few things. And our cocktail is actually a set of 6 factors, 6 set of instructions that are precisely telling the cell to reset. If you were to think of how it actually happens, is a structural resetting of the cell relaxes and then tightens up. And through this process, the cell kind of shakes off those issues, those aberrations that it developed throughout time. And then the cell is able to read your code, the song that you are, in the way that it's supposed to. Now, this we've noticed to be a safe and long-lasting therapy. So we haven't seen any cancerogenesis or oncogenesis. We haven't seen any issues because mRNA at its core is transient. It's got a short-term half-life. And the way we approach it is we encapsulate it in a lipid nanoparticle. This lipid nanoparticle itself is transient. It has a short-term half-life. It's able to be seen as food by the cell, and it's eaten. So I don't know if there's here it is. So if you look at it won't work? Okay. Okay, perfect. No worries. So if you look at what it ultimately is, our molecule, our therapy, we have the mRNA inside a lipid nanoparticle. It's encapsulated inside. Oh, thank you so much. Really appreciate it. So we have this is our therapy, right? We have our mRNA, we have 6 factors in there. And it's a set of instructions ultimately encapsulated in a fat bubble. Now it's a very sophisticated fat bubble because this fat bubble, needs to go through your body and address the tissue that is specifically designed to be reprogrammed. And we'll talk about that, what tissues we're reprogramming shortly. Then we go from there, and then you see it right here, the cell sees it, it opens up, it sees it as food. And once it gets inside the cell, the ERA factors, the factors, we call them ERA, epigenetic reprogramming of aging, our 6 cocktail factor, opens up, it gets deployed, and then the protein making machinery begins encoding for the reset. The cell goes through this reprogramming. Now, some of you might be familiar with the process of induced pluripotent stem cells, where you take an adult aged cell, like a skin cell or a muscle cell or whatever it is, you can turn it all the way back into a pluripotent, omnipotent cell type that then you can differentiate into something else. Maybe you can turn a skin cell into a brain cell or a muscle cell or the osteo cell, right? What we're doing ultimately is using the power, harnessing that technology, but we're not taking the cell all the way back to an embryonic stage, an omnipotent stage. We just make it a younger version of itself. Because just like none of us would necessarily appreciate being 1 day old or 1 month old or even 1 year old, because even though you're young, it has its downfalls, being that vulnerable and fragile. The same thing with a cell. The cell loses the ability to know its role. It no longer is a skin cell, no longer is it's a cell that is beneficial for your body. So what happens is we tell the cell to reprogram itself. It's a very specialized, time-optimized process. And then what happens is the epigenetic dysfunction ends up getting addressed, and then it tightens up the epigenome. The function epigenome ends up, ultimately resetting the cell's ability to perform at a youthful level. We have plenty of data. We have plenty of posters. In fact, 2 weeks ago, we presented at ESDR, one of the world premier dermatological conferences, and we showed that one therapy of ours can reverse back 10.4 years of aging in a skin cell. And we have data in keratinocytes, fibroblasts, and all sorts of types of cells in the body. Now, the question is, when you can rejuvenate any cell in your body, where do you start? Well, we have opportunities in the ear, the skin, the immune system, right? We want to have a young immune system to fight cancer and diseases, musculature, ophthalmology. And I know that I don't have a lot of time left, but during the summer, after several years of negotiation, we were able to announce a $300 million deal with a pharma from South Korea. We're in the process of working 2 other business development deals. Hopefully, you'll hear them soon in the realm of, or in the space of skin and dermatology. And that's where we pretty much focus our attention. Even though our potential is big, we liked skin because nobody wakes up saying, wonder how my spleen is looking today, right? A lot of us wake up, look at the mirror, and we see the difference of aging as we go through life. But there's also the beauty component, and there's also the pharmaceutical component, because the skin is our biggest organ and is the first line of defense against the world, against disease. So we have opportunities both in the aesthetic and the dermatological aspect. And of course, with that comes hair follicles because they're embedded in the skin. So where do we see ourselves? We see ourselves as providing, so everybody starts asking, because by this time, everybody says, how do I get on the list? Well, we got a pretty long list. But the way it's probably going to work initially is through microneedling. It's very well understood by dermatologists. It's going to be deployed in your skin. And then you're going to see this transformation happen in the following weeks. We can see benefits. So we did a study in mice for muscle. We saw benefits 6 months later from a wound injury model, just in muscle. So we haven't done this study in skin yet, but we haven't done that particular study in skin yet, but we do have a robust set of data that we want to achieve. So I'm going to also, and thank you for the extra time. I know I just got 2 more minutes. I want you to know, because there's always a question, how soon are we going to get to market? We have already spoken to the FDA. FDA gave us what's called an interact meeting. They don't give a lot of those in a year. They chose us because apparently not a lot of people, if any, are doing multifactorial mRNA therapies. Most mRNA therapies right now are vaccines, not really therapies, they're vaccines. They're single mRNA factors. And they wanted to know how we're going to do it. They wanted to know what our lipids were. And they got very, very, very excited about what we're trying to do. They gave us the interact meeting and they gave us guidance on how to go through the regulatory process. Of course, that means because we have really 2 platforms, the mRNA platform and the delivery platform, we can not just license a product that's going to make our skins look great, but then eventually is going to help our other parts of our body feel younger and become restored. We also have the ability to out-license our delivery technology. If you have a DNA, if you have anything you want to deliver specifically to any part of the body, talk to us. We're happy to do that kind of pharma deals. And then, of course, that's backed by our extensive IP strategy. We have 8 different IP families of IP. And then we have a team that is just ready to solve the issues of age-related diseases. We have a team that has been involved in public, private, And we love for you to be part of our team somehow. So let us know how we can partner up. Thank you.
Thank you. Thank you for Turn.bio, and now we are open for questions. Okay. We'll have break right after this.
Yeah, thank you for sharing the results. I just want to clarify two studies that you mentioned. So first of all, on the animal model, as I understood about the muscles, I just want to clarify the results. Can you probably tell us more about that?
Sure. So the reprogramming didn't happen in vivo; it happened ex vivo. So they took the cells, the muscle cells, ex vivo. They reprogrammed and made them younger versions of themselves, and then they put it back into the mice. But the mice were older mice, and what they did is they injured two legs. One received the treatment, the other one did not. The one that received the treatment, in other words, the reprogrammed muscle cells went in there, rejuvenated like a young mouse. 6 months later, now my mouse years, that's what, like a sixth of a lifetime, they re-injured the mouse. And they showed that there was still rejuvenation at a younger level. There was some loss because the mouse kept aging, but it was still regenerating at a younger version of itself.
How many mice in the study?
Oh man,
sorry for
that was
probably very detailed questions.
2015, 2016.
Have you
So I'll
published
send you the
that?
paper. Yeah, I'll send you the paper.
Right.
It came out in Nature.
And about skin, I just didn't understand. You mentioned that you just received the results, but then you just told us that you haven't received.
We received the data results that we published.
Yeah, just 4 years or something like that. Using
10.4 years of rejuvenation. At being academic and actually getting a product out of two different things. So I wouldn't put this in you just yet because we're going through the manufacturing process right now. We want to get human grade material because we care about safety. It'd be terrible to get older because you're trying to get younger, right? So we really want to be conscientious and ethical when it comes down to it. So right now, all our proceeds or our focus is how do we get into the clinic? How do we manufacture this? And you know, it's really just a manufacturing issue. It's no longer, thankfully, an bioengineering issue.
Have you started PKPD modeling based on animal data? Cool, thanks. Yeah, congrats.
And a question.
Thank you. I have a question. How often do you envision delivering this drug? And given that you're delivering transcription factors, what is your risk mitigation for cancer?
Right. So you say delivering or administering? Because there's a difference. So delivering is through lipid nanoparticle, and administering, it depends on what we want to target. But since it's skin, and since there's a lot of investment dollars in the derm world for doctors, we're going to have either a 30 gauge needle or a little, very fine microneedling devices that would address initially potentially your phase. But there are other places that people will pay for this.
I was wondering more about the frequency. Do you see this as a one-term?
Right. So now that's a dosage question, right? That's an optimization question. It's a good question where you can rejuvenate 10.4 years with one very powerful technology. I mean, does it make sense for us to break it up so that you're only rejuvenated every year and you keep coming back for more? I mean, these are questions that will very much be asked and addressed at a clinical stage. You will find different tracks, and we are very excited to get into humans. And we're very excited to answer that question. That was a great question. Thank you.
Thank you for your presentation. I had a question about reprogramming. So reprogramming changes the gene expression back to a more youthful state. It doesn't really change anything about DNA damage or mutations that accumulate over time. So how are you going to address that in your treatment?
Yeah, so we ultimately, while we are focused on extending health span and lifespan, we're to truly live to be 200, 300, like Johnny Adams once, we will need several therapies. This is why partnership is so important. There are genetic editing tools that are now coming up that will probably address these issues. So somebody who has a genetic aberration will get benefit from our therapy, but ultimately that genetic problem would stay there until another therapy will come in. So that's a important thing to know. Great questions, everyone. Ranja.
Question from the Zoom. Have you seen the movie Substance? And has that set you back 30 years? Seen the movie Substance?
I have not, but now I wish I.
Now you need to watch it. Okay, that's no need to comment if you haven't seen it. We don't want to spoil the give you the spoilers. It should be required watching for all longevity companies.
Good. Yeah. No, I'm assuming it's a regulatory focus.
No, you should just watch it.
We'll have an R42 watching party.
When's how much will it cost? So suppose it's ready, whatever.
Yeah, those are commercial questions that we need to figure out. In the case of our ophthalmology drug that we just partnered up with Hanal from South Korea, that's going to be a question that we both need to answer, right? Because they're investing upwards of $300 million to get this to the clinic. So and beyond that. So it's like with anything, like the first one is always millions and the next are not that much more expensive. But with scale ups and such, I mean, this could easily be a few $100s. I could tell you what Sergio wants. I want this to be as accessible as possible. I want this to, we're partnering up with governments so that we can make this as viable as possible. Our manufacturing facilities are actually global. Those are the deals that we're really focusing on right now, is with companies that have manufacturing in India, in Europe, and in the US, so that we don't have to have a lot of overhead costs. Great question. Yes, sir. Gracias.
Mexico, talking about accessibility, the price and the go-to-market when the time comes for massive markets in emerging territories and emerging regions like Brazil, Mexico, of course, Bellísima Colombia, etc. What do you foresee on that?
So the question was, and I want to you're asking the time or the distribution channels?
Go-to-market snapshot for emerging markets.
Yeah.
Where accessibility price point is an important factor, but at the same time, the opportunity, as you know, in our markets,
it's huge.
It's huge.
Yeah. These are questions that I believe, I mean, unless somebody here in the audience wants to write a $100 million check today, will be answered with a pharma partner. A lot of these pharma partners already have footholds in all this. Mexico has great manufacturing also, for example. And the current model is a model that has historically burdened the US population to subsidize other populations. So I think that's all kind of changing and very dynamic. My goal is we rejuvenate the skin, and then we have, dozens of other organs that we need to rejuvenate. So do we have to make all of our money in the first 100 organs or the first 100 cell types? No. I think it's a hard question to answer right now.
Okay, let's have one last question.
Yeah, so we have to admit, we've lost some money on a Korean gene therapy company that kind of failed in the last stages of clinical trials. on
Sorry about that.
skin applications, but I mean, sounds great. The little bit that I could tell, to the extent that the cells have, DNA damage, maybe it's even early stage cancer cells. What does your treatment do to those cells?
Right. So when we do target a certain environment, and I want to say a certain tissue is a population of environments, even the skin has immune cells, right? So we're doing a global resetting of the entire environment. And this is why we see that, we've gotten much better now, but even if you're able to reset 10% of the population, you see the environment gets better and younger. So first of all, the simple answer is we haven't seen cancer creation. We have seen even third-party labs have done reprogramming with a cocktail similar to ours in cancer cells. And what happens is it kind of deactivates the cancer a little bit, which is really interesting. But alongside any potential potentiation of a bad actor, there's also the rejuvenation of the immune system, and the environment itself we've seen takes care of those bad actors in a much better way. We don't have time here, but I would love to show you. We also have an immune program where we rejuvenated T cells, and we set it up like battles, right? Cancer cells, T cells, and they have engagement. And by the fourth engagement, a normal T cell gets exhausted and the cancer takes over. When we presented, and just one more minute, when we do the reprogramming, the cell keeps fighting the cancer and then it proliferates better. So, yeah.
Okay.
Thank you so much.
Okay. We shared office, so we all cool. Okay, so now we're gonna have to break for 15 minutes. We're going to get back by 4 p.m. We are a little bit early, and we have some healthy energy bars and some unhealthy brownies. So go enjoy. We'll be back.
Thank you. Thank you. Thank you. Yeah, Johnny. Yeah, I think we have. Thank you so much. Oh, thank you so much. Oh, thank you.
Felicidades, Sergio.
Muchas gracias, aprecio mucho.
Un fondo de inversión acá, ya vivo desde hace 15 años acá. Estamos invirtiendo en videojuegos, pero estoy súper interesado en longevidad y wellness, etc.
Oh, sí, claro.
Invertir en una
¿Sabes quién
empresa.
invirtió en nosotros? Shanda creó uno de los juegos más Shanda Group, Shenton Kiao.
Oh,
yeah,
okay.
That's him.
Oh, okay.
Yeah, Estados Unidos, 20.
15 también acá, pero solo aquí. Está increíble lo que están haciendo.
Ahí estamos.
Invertimos en una empresa de CBD en Guadalajara que está empezando a productos basados, obviamente no tan científicos, pero para apoyo a longevidad, wellness, etc. Tiene súper interesado este mercado. Así que todo lo que pueda hacer para ayudar.
Gracias.
Tenemos buena relación con el grupo Carso.
Carso, okay. Sí, sí. Si me puedo. I'm doing a little 5 minutes.
Looks like you look like 10 years younger. You look like you're going to like football.
Exactly. Okay, so did my slides work? Do you you have a USB? Yes, I have my laptop.
No, I didn't have time. So we got 10 minutes earlier, so Arden Swaza first, then you, then Bert, then XPRIZE.
Okay. La compañía está aquí en.
Tú vienes muy seguido.
Sí, exacto.
Bueno, yo estoy aquí en Belmont.
Oh, nice.
Está 10, 15 minutos en coche por acá.
Excelente.
Y tengo muchísimos amigos en Bogotá, ¿de qué parte? Yo soy de Medellín también.
Yo tengo familia allá, pero yo soy de Bucaramanga.
Ok.
Soy las ciudades terceras.
No conozco.
I have both.
So you have great.
Yeah, I was like, you look like you just did out
Hey, thank you
football.
so much. Sorry.
Thank you.
I just wanted to finish the answer.
I know,
I was
sorry.
like, oh,
Yeah, I
wait,
really
no.
have cut it, yeah,
Yeah.
yeah.
We're running early, so that's good.
We are running early, but I suppose to do R42 funds.
Yeah.
So we're gonna do that after.
Okay, that's
Yeah.
good.
Yeah.
That's good.
Yeah, I'll see you around in VRP.
Thank you. Yeah, see you around.
Oh, Turn.bio is fundraising, right? Turn.bio is fundraising.
Yeah.
Okay. I will follow up the people who are interested to you.
Thank you. Thank you.
Okay.
Yeah, I think right now, yeah, we'd be happy to do a little convertible note event for this.
Okay, how much are you looking for?
The convertible note, we have a couple of people interested in putting in $1 million or $2 million. We're only allowing about 5 million.
5 minutes, so it's kind of like bridge.
But altogether, our Series B is gonna be probably 30.
God.
30.
Okay.
Yeah.
Okay, great.
All right, thank you.
Thank you.我犯错误了，刚才应该是这是哪儿讲？
Can I make 5 minutes? You don't have 5 minutes. And you can.
No, I know. I have a power bank you can use. It's a front desk. You can just grab it. Yes. 这是第二个。 No, we
Still.
This one is damaged. Works? No. 我没选的是个老爷爷，我待会儿知道。
How can I help you? Make it work.
Superbio.
聊一下对，不好意思，我先处理一下。好的。天哪
Try this.
Try again, yeah.
How do you flip it?
I bought it like yesterday.
Okay. Stress.
So did you play football before?
No.
Basketball.
Basketball. Soccer. So, all right. Okay.
Gary.
Okay.
Oh, I see, that's the company. I was wondering,
Inject.
Okay.
Superbio.
是 Perkins， 马上 Perkins 其实我昨天给你介绍，这是我们自己他们做的蛮好。
因为有一些我是看出来的，可能这个。
对 Superbio 比较容易好理解一些。
对，那我们在喝酒。
Press repair.
No, that's the older one. That's the old file. It's not loading.
Yeah. You want to try plugging in my laptop?
No, just do PDF.
PDF.
Yeah, that's good for to PDF. Ah, okay, that's why. How about this one?
Can I email you?
No, this doesn't have network.
Does not have network.
Yeah, this one has no network. Oh God, why? Yeah, you need Wi-Fi? Yes, but this one cannot be logged into.
No. This is, yeah.
Are you presenting?
I am.
Does this one work? Does this one work?
Works? Press enable. Cool. Okay, great.
Let's make it work.
Yeah, click on that screen. Let's see. Next one. There's like a video there, and then go down. I'll tell you where else I need the video on. Right there. Go up. Up. Right there. I need this video on as well. So when we present, I'll just press play.
Okay, you'll just be this one.
It's very impressive. It's very interesting.
Yeah, I only sent it out.
Okay.
Okay, so the field apps have disappeared in the field. Okay, that's fine.
Okay, all good?
The video works.
No, the video doesn't speed in.
Can I give you the?
You can download the video and give to me now.
The video is in. The video is in.
Let's see if that works. Okay,
How do you do it?
just click on it. It works. I'll just preload it. I'll just leave it here. Okay. I'll just leave it here. I'll just open the new tab. Should work. Okay.
I don't understand. So go back to the PDF.
This is PDF. You just click on it. It works.
Click on it. Okay, go back to the video slide.
Yeah. Yeah, he's here. Mark camping. I didn't know.
Oh, well, you have the list. Okay, so if I go here, here, then what do I do?
Just click on.
And then it opens up in a new tab.
Yes.
And then I go here and I see.
Yeah.
See, now I'm on to, where is my person? Oh, yeah, I have to go back here.
Yeah, I'll help you on that. Don't worry.
Okay.
I'll be there.
And then I go here.
Yeah, just keep going.
Then I keep going.
Okay. 15 minutes. No, 15 presentation and 10 minutes Q&A.
Okay. So the schedule, it's like
No, 15 minutes Q&A. Okay. You just got back from New York?
Yeah. And I'm flying out one day.
Where? Where in New York?
Zurich.
Zurich, for what? Conference?
That was the Bentley launch.
So you were there?
I think 8 hours to go.
Ah, okay. It's good. It's good. I miss some super rich people. I mean, yeah, doing fun. One is like a foundation owner. The other is like construction, like sperm forge for Brazil. Okay. If they can buy a like $500,000 car, maybe you can invest $1 million. Yeah, they actually give a free bottle of wine with Binley logo on it. It's a good one, actually. Good one from Napa. Yeah.
Yeah. Let me get my.
Okay. Oh yeah. You did it. Oh, it's gonna be 50 years ago. Yeah, oh, sorry. Hold on. Okay, right. Okay, no problem. Well done. Oh, thank you. We've got hills. Right. Oh, well, very nice. You're not running. Why are you running? Oh, not running with him. Okay. Yes, exactly. 10 miles. 10 miles.
10 miles in 6 to Not for 2 years. And then I use the rice. Decide my body. So this is in. Yes. Yes. It will be. You just have to roll with it.
Okay, so this is what I'm presenting. Let me show you. So this slide, we just talked through this, blah, 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 all the way to this part. So I'm gonna go roadmap and then say Swaza can also do lung cancer. And so I have this paper, hyperbaric oxygen suppression. And then I have this paper, HIF1 alpha stem cells. So what I'm gonna say is like, I'm gonna say like, there's been multiple studies that have been published on the aspect of oxygen imaging. So now what I'll say is like, oftentimes there's a lot of papers that have been published on oxygen in a tumor microenvironment. And I'll show the two papers, and then I'll ask Jay, can you please tell us a bit more about how that works on a scientific level? When I go to this slide, this is all like talk briefly, and then I'll say we're also developing a enema, which has recently been recognized by the IG Nobel Prize. Jay, can you talk a little bit more about the science behind that? And then the team advisors, that's it. Super simple. Yeah. So if you want, you can kind of hang out on the front here.
Yes.
This one. But yes.
Eric Meriden is here.
So why? No, why? Why you want to work with them or something, or?
No, I just, I have to move my lab, right?
Yeah. Oh, you have a year. Okay. Okay. Well, hopefully by then we have enough funding so you don't have to move anywhere.
You sure?
I said hopefully. Yeah. Yes. There was maybe half of them. So I think it will be
1 year, 20 days.
Oh, you're counting already.
So, but I mean, of course, that renewable, they made it a renewable, distinguished the scientist position.
Okay, so that's better. Yes.
I mean, so I'm reviving my UCS position as a kind of paid position now, so I'm talking to them. So that means, who knows, our mountain view lab likely to move that side also, the place where you live.
Well, I mean, we'll see. We have a year to figure that out, you know.
And not that much, because for a lab move, it's a very less time I need to.
You have a lot of chemicals to move. It's like a lot of machines and stuff. I was saying like, yeah, like maybe we could store all this stuff in the Swaza facility, but I'm like, that's a lot of chemicals.
Yeah.
Needs to present it to like.
Mainly I'm worried about equipment.
Yeah, and the equipment too. But yeah, that was your day.
Yeah, I just, I submitted a grant renewal with Joe. I'm a PI.
So yeah, I'll be talking then, well, probably I'll just grab a mic. Just hand it to you, so it's easier for you.
So I have to explain the mechanism.
Briefly, so like we did today on the native call, briefly, so when I get to like, you know, here are papers that we publish, and then when I have that mechanistic thing, more high level, like 30,000 foot why this will work. And then when I go on to the enema, also just like high level how that works. Well, it will show and tell maybe a future direction. So this is all prototyping and stuff like that. Anyway. But yes. Have an all-day board meeting. Okay. Where's your baby?
She's in Palo with my mom.
Ah, I'm like, I hope she brings her.
I was thinking about it.
Why not?
She's still the show.
Exactly.
You'd be presenting.
That's totally fine.
Okay, next time.
She can help.
Yeah.
She can help. She can help fundraise.
Sure, I can just like bring her. Okay, so I'll do that.
Seriously.
Are you going next? Okay. What's that?
He said I should do it before.
Before?
Yeah.
Oh, but now.
I didn't think I was my situation. No, nothing else.
That's fine. Hello. Okay. Oh.
Sure. Whatever. It's well, yeah, it's totally fine.
Okay.
They're all products.
Really?
Yeah. Yeah.
Yeah. Wow.
We actually have stuff.
Yes, and especially since everyone is searchable now, you know, so like. Very nice to meet you. Good luck. You would intern. Yeah, I know you too. You're often.
I'm mostly based in
Oh. Yeah, well, I did not thought about it. I've been in Palo Alto.
Very well, I did some early investment in the same house. With the mom, we're about
How do we get people to come in? Yeah, yeah. On the Zoom, yes. Yeah. All right, let's get started again to get right on time. We're going to get progressing. Let's see, I think we're trying to get people from the coffee. I'm going to put my coffee down. We have 5 minutes before. Oh, just let's sit in the front.
I brought Chantal.
Is there awareness? It's almost like then everyone will want to use it. Yeah, why not? All right. Let's see. I think if we're just getting started.
Yeah.
Yes.
Oh, hi. Great. So we still have people missing. Okay, well, yes, we'll just do a quick intro on R42. So my name is Anastasia and I'm a principal at the fund. And we are actually, we are a venture fund and also an institute, a think tank. So we focus on AI, deep science, and longevity, early stage, at the early stages, and we invest in UK and US. We also have an institute, which is the R42 Institute, which is a think tank, where we have a few things going on. We have a fellowship for students and also professionals during the summer. We provide free AI education. And then we host many, many events, offline and offline, really just for us to learn, for everyone else to learn with us, and of course, for us to look at new companies and to help our current portfolio companies. So in fact, the majority of companies who presented today are R42 portfolio companies. Hope you enjoyed the presentations, a few more to come. Yeah, so in terms of the fund, we've invested in about 50 years, maybe almost 60 AI and biotech companies. R42 hosts events like this. So usually these are for our LPs, which we have a few of them here right now, but also for other investors, co-investors, in the industry. And then we're also hosting the Stanford Longevity Conference, which is called SALTS, which is going to be January 17th. So we'll share everything after this event. So welcome to come. And the R42 fund started 5 years ago, led by Dr. Ranjan Nag. He already presented earlier today, but he is a distinguished professional, serial entrepreneur, and recently awarded also Silicon Valley Engineering Hall of Fame Award. He's invented companies that he sold to BlackBerry, Motorola, and Apple, and he's done very good investments. And then he's now also adjunct professor at Stanford Department of Genetics at the School of Medicine. So we're very much embedded with Stanford, with other universities such as Cambridge, Harvard, but we of course look at companies outside of those universities as well. So R42 Fund is led by Dr. Ranjan Nag, who is, has an extensive career track record of investments. We also have Zishuan, who is in the team. He's venture associate, and then also Artem, who is entrepreneur in residence. He's also been there from the beginning, and he will be presenting Swaza, also R42 portfolio company. So we're very active. I think we're one of the most active AI and longevity funds out there. And you can get involved by, we're actually launching currently we have 3 funds, and we're launching our 2 other funds in 2025, a seed fund, same as, the first 3 funds, and then also a growth fund. So if you're interested, please reach out. We also have a fellowship. We have an incubation program where actually one of the companies is Superbio.ai. They'll be presenting later, ML platform for life sciences, and also Agemica, that Ranjan Nag already mentioned, which is developing vaccine for aging. XGenera is, was that? Oh, next 10 years. Sorry, yes. Was that? Was that? Oh, right. Yes. And that one as well. Yeah. Yes. So great. So, okay, well, I think, do Do we have anything to add, perhaps? Yeah, great. Okay, and I'll let Artem to present Swaza.
Okay. This one? Okay. So I'm going to start off by asking you guys, how many of you think oxygen is important? Raise your hand. Well, for all of you that didn't raise your hand, first of all, I want to know why you don't think it's important, but we'll get to that. But at the end of this talk, I hope that you will believe that we can make oxygen great again, because that's what we're doing here at Swaza. So without further ado, let me just jump right into it. So what we've developed at Swaza is a number of assets, one of which is asset one is our nano emulsion that actually I brought show and tell to show you guys. This is asset one. This is our nebulized nano emulsion that we are using for delivering oxygen into the lungs. And I'll talk more about that later. We have a wound healing biomaterial. I don't have that with me today. I have our thermal reversible enema. This is more for battlefield deployment and austere environment development, and Swaza topicals for all you face-loving people and cream-loving people. This therapeutic over here does the same basic principle, uses oxygen, travels through your skin, and is able to penetrate and deliver oxygen into areas of low oxygen, and is able to reperfuse and infuse the body with a lot of good nutrients. So a lot of things that are happening. A lot of the works for the IP related work is handled by Dr. Janet Shao with Morrison Forrester. But I'm going to talk more today about Swaza 1. So back in the day, and this is actually real, since the 1960s, it's been known that you can superoxygenate fluids that can replace air. And then there was this experiment done in the 1960s where they had an animal suspended, a mouse suspended in a solution, a breathing solution, and it was able to live for 3 weeks. But we don't really want that when it comes to people. We really want, this, like the proof of principle is drowning. We don't really want to drown people when they're talking about like, oh, we're going to infuse you with oxygen. So we're going to fill up a tank of liquid and you're going to breathe the liquid. That's not what we really want. We want to have some sort of other solution that allows for people to have oxygen be delivered into their lungs, into their system, and not have this. So our first asset, as I mentioned, is tackling a big problem of respiratory illness. It's the #1 threat in developing countries and actually the 3rd leading cause of deaths worldwide. Many of you maybe have been more exposed to this with COVID, but a lot of people are still suffering from damage to their lungs with COVID. And it gets worse as you age, as there's more pollution and there's increase in respiratory complications. This is something that's super important for longevity. And our first asset really transforms the way in which we think about breathing. We are tackling diseases that are going after COPD, respiratory infections, you're talking about asthma, and restrictive lung disease, and so forth. So you might be wondering, how does this magic stuff work? Like, what is it actually that we're doing here? I showed you a liquid, and you're like, how does this actually work? So we really want to target the fluids and protein barriers that block oxygen uptake in the lungs. So this is an image of a lung vesicle, that alveoli that does not have enough, that has edema in the fluid and the lung buildup, and you have a barrier to oxygen transversing down into the bloodstream. And so I have a nice video to show you about how this asset actually works. So there's no sound.
That's because we put the image of Forrester on screen.
Clearly. Let me start this one more time. Mike picked the wrong law firm when I was presenting that one. All right. Okay, well, I'll walk you through it. So what's let's gonna play again. That's fine. It's gonna play again and I'll walk you guys through it. Here, Jay. So what you're seeing here is you're seeing our vesicles, these small nanoparticles that I'm gonna walk you through verbally again. Let's play this one more time. Play. There we go. All right, so this is a single dose for a human that is nebulized through a nebulizer. And when you're nebulizing it, it perfuses into the lung, into the alveoli. The particles here go through the inflamed alveoli, and they are able to capture oxygen from the surrounding environment through the edema and into the blood barrier, and are able to drop oxygen into that blood barrier. They cycle that continuously until oxygen saturation is received. So one single dose of this is enough to sustain someone for 24 hours with oxygen. I'm hoping to convince you that oxygen is great again. I'm still trying, we're getting to that point, but I'm still trying, we're getting there. And so for this first asset, not only is it portable and is stable at room temperature, so I don't have to cold storage this or anything in that capacity, but also it really works as something that does not need any fancy equipment. You can use any nebulizer. You put this as a single dose and it works. Not only that, it uses safe and previously approved FDA ingredients, meaning that we're fast tracking through FDA approval as well. But I'm talking a lot about all the theoretical. This is actual data. This is efficacy experiments that we ran in a rat study. And what you're seeing here is that in a rat study that had lung injury, one dose of this is able to elevate their blood oxygen back to baseline as compared to animals that are injured. So, see this point it works now. So the gray that you're seeing, those are the dips in the animals that do not have enough oxygen in their arterial blood. The green line at the top you're seeing is normal, healed, or not injured animals. And the blue that you're seeing is reversion to baseline just with a single dose of Swaza. We're going after big markets, starting with ARDS, which is a $17 billion market. But we're really going after 230 patients have ARDS every year, but the market itself just is massive. We have 56 billion in market cap here, and just with asset one, not talking about the rest of them. Okay. Moreover, we are a government contractor, so we have revenue coming in to the company. We provide. So this first asset is going to be provided as part of the strategic stockpile for public health emergencies. We are recognized by the Assistant Secretary of Health and Human Services for this innovative technology. We're also part of the Johnson & Johnson Blue Knight program. And we this morning pitched the NATO Diana Accelerator. So this is the Defense Innovation Accelerator of NATO. We are in our first asset, the one that I showed you, is going to be in phase 2 in 18 months. So if any of you are investors in the room and you're looking on a quick return on capital, come talk to me after my talk. Because we actually have a product and it's ready to be shipped. Very close to that. Okay. But not only that, so I talked about this aspect of nebulizing oxygen into your lungs. But the cool part about this is what we could also do is we could target cancer in the lungs. There's been a few papers that have been published about how hypoxia in a tumor microenvironment and treating it with oxygen has a beneficial effect. And I'm just highlighting some papers, but I wanted to ask Jay for you guys to meet Jay. He's our Chief Science Officer, and he wanted to talk a little bit more about the mechanism behind how this works. Jay, if you want to come up here.
Yeah, so the Swaza, especially for lung cancer, not only for lung cancer, to improve T-cell therapy also, you can
stand here.
Improve the CAR T-cell
therapy to totally even get rid of the T-cell exhaustion that happens when they are undergoing the therapy. With the Swaza, it's possible. How? Because this is the main transcription factor, HIF1 alpha. It's also a Nobel Prize winning discovery where people found out how tissues recognize there is a depletion of oxygen. So they can just improve the methods to improve the vascularization because of the depletion of oxygen. Unfortunately, this very transcription factor is kind of reason for mutations, enormous mutations in the cancer stem cells. And also, because of its activity in the CAR T-cell therapy, in the CAR T-cells, when they have a HIF1 alpha highly upregulated, they don't kill the cancer cells anymore. So, by just delivering Swaza fluid, we can improve oxygen. So, you can see that. So the HIF1 alpha is stable and it is unstable without of enriched oxygen. And also another thing, Swaza can deliver the fibroid functions, the way cancer stem cells they survive. So and then there so that exhaustion
That's asset one, but one second, Jay. We also have asset three, which is our thermoreversible enema. And this is fresh off the press. These scientists discovered that mammals can breathe through their anuses, received an IG Nobel Prize. This is real. I'm not making this up. There's been a paper that's been published, and our thermoreversible enema does this. And Jay, maybe very briefly say how this actually works. In terms of the
so in fact, this one. Aqueous enema. You can't hold it for even just 15 minutes. It's very difficult to hold it. Why? Because there is a lot of senses. So, nothing if it is low viscous. So, at the same time, it is very, very difficult to inject a gel. So, what we came up with an idea of what if something, it is a very fluid in a room temperature, the moment it becomes jelly. So, that idea, it worked, and people can hold it for and so even 3 to 4 hours, they can hold the solution. So the same way, the Swaza fluid enriched the fluid, people can do, when they are there, they have problem in breathing. They can have
has this hygiene of and then still
And, we're not saying we're gonna have you breathe that way, but the idea is that, thank you, Jay, is that this can be used in far forward deployment and battlefield scenarios for wounded soldiers, as well as for patients in the hospital who are immobile and need some additional arterial blood oxygen. I have just gonna highlight 2 more slides and then I'll be done talking. So this is our team, with Jay being our CSO and Nikki being our CEO. Our advisors, some of the names you might recognize, Dr. Mike Snyder, Paul Weiss, it consists of a lot of folks who have been accomplished in various areas. I'm going to stop at this slide, and if anyone is interested to learn more, just scan the QR code there, and you'll be able to learn more about what we're working on. Right, 5 million on 15, and 25% of that has been committed in this current race.
How much been raised before?
2 million. So all the assets that I've shown you, it's non-dilutive, yes. All the assets I've shown you have been developed with very lean budgets. Yes. Out of non-dilutive, 750K is non-dilutive, the rest is equity. I think it's question time, right? Yes. Oh, that is a question, okay.
Question about the, maybe a scientific question for Jay, but what actually happens is, you mentioned there's multiple tumors we can address, and you showed an example of lung cancer. Is that non-small cell lung cancer, as well as what is actually happening is in the mechanism? Is it like degrading the tumor microenvironment? And then how would you address other cancers, either solid tumors or even blood transfusion or cancers?
It's a wonderful question, and so the mechanism by which the Swaza is helping the tumor removal is by, as I mentioned, it promotes the oxygen. It supplies the oxygen to the cancer stem cells, and also even in the blood cancers, it's possible, because most of the blood cancers are basically marrow derived, and in a marrow derived, they are in the niche where you have a lot of fibrotic lesions there, and then the Swaza fluid can enter there. We have a data to show that other material, other chemotherapy agent, you can't deliver it. Why? Because all the fibrotic lesions, it's kind of nesty, and they never allow any delivery there. Swaza fluid have the capacity to carry the chemotherapeutic agents and deliver it to the niche, so that you can have a complete eradication. In fact, if you have a tumor organoid, let us say, then you can even show where exactly the cancer stem cells reside. They reside inside, interior, where there's the least oxygen diffusion there, because they need plenty of HIF-1 alpha upregulation there.
Yeah. Generally, tumor microenvironment is hypoxic, and so when you infuse it with a bunch of oxygen, the microenvironment becomes less hypoxic, cells grow slower, ergo you can slow the progression of cancer.
Really fascinating. So how do you release the oxygen slowly? Because I was seeing some of your numbers there. It's effective over hours. So how do you embed the oxygen in order to do that?
So the nanoparticle structure and the way that they're structured themselves, they're able to shuttle oxygen continuously. So they are able to absorb oxygen from the surrounding ambient air, then shuttle into, by just a density gradient, down into the area in which the diffusion happens. So at this case, with the blood barrier, you have diffusion happening at the penetration level. At that point, carbon dioxide is shuttled into the oxygen, into nanoparticles, and the cycle is repeated multiple times. So we're not specifically infusing, like super saturating these nanoparticles with oxygen and then infusing them. The technology in itself captures ambient air, and so it can shuttle multiple times. And in the rat study data that I showed, we're able to have a sustained effect over the course of 24 hours. So not just a single boost is a single up and then it goes back down, but it increases arterial blood gas and then sustains it for 24 hours.
What's the cost of a dose? And is there, you showed COPD there, interest to me. Is there a model whereby someone would dose daily, for example, and can you achieve that economically with the cost of the fluid?
Current cost of a dose is what, $25 or so? And that's going to scale down as we scale up. So the idea is, yes, this is a therapeutic that is an additive to treatment, but we're trying to tackle the biggest problem in a lot of the respiratory illnesses, which are low arterial oxygen. And how do we do that without a ventilator, without a oxygen mask, and a lot of other things? So making it as simple as easy to use as possible.
So could this be used for people that have asthma? And if so, is it something that they could eventually buy over the counter and use at home?
Ideally, yes, in the future, we'd like to have it be available for anyone. But whether or not it's going to be over the counter will be dependent on the regulatory agencies and their approvals there. Good question. So hopefully I convinced you that we want to make oxygen great again. And if you want to learn more, like I said, scan the QR code, but otherwise find me after the event. I'll be around.
Okay, thank you. So the next company could be XPRIZE.
Thank you. So my name is Silvia Veronese. Closer. Can you hear me? Okay, my name is Silvia Veronese, and I am the CEO and founder, together with Ron John, of X10E. So before I proceed any further, since I get this question all the time, why did you choose that name? I'm a mathematician by training, a computational biologist, turned into biotech because of my passion for data. I really started my career with a fairly large, big challenge, which was studying modeling of the heart. And while doing that, we built the first parallel computer. So fast forward a number of years, here I am with another moonshot mission, which is really the transformation of how doctors decide on how to intake medical procedures. So we all have done blood tests in our life, some more frequently than others. Reality is that 70% of medical decisions are based on invasive laboratory tests. We need to go to the doctor, go to the lab, do the blood test, needles, and so on. A lot of people, more than half people, do not follow up with their doctors, do not do their physicals, and so on. So our mission at X10E is really to develop a technology, a novel technology, which is a combination of multiple disciplines, from hardware all the way to biochemistry, that can effectively substitute, replace a blood test, and doing so in a non-invasive way. Why is this important? Because if you take any biomarker, hormones, electrolytes, metabolic markers, they vary during the course of a cycle. That cycle could be seasonal, could be weekly, and a lot clearly is changes during the day. What you see here on the screen is an example of blood pressure. Two patients, one red and one blue. We all know that blood pressure rises when we are under stress. We're in a meeting, we're about to go for an interview, but very few people also understand know that, for example, a marker like blood pressure changes during the course of the night. And I bet not that many people go to the doctor at 5 a.m. Why is that? The specific case of blood pressure rising in the early hours of the morning is due to the fact that we are waking up. Our sympathetic system is waking up. There is a phase between deep sleep and being fully awake. It's actually a fairly important time of the day from a cardiovascular standpoint, because we're very likely to have a heart attack. People are very likely to have heart attack during those early hours in the morning, and which is something that we do not currently monitor. Variation of blood, of biomarkers can be anywhere between a few percentage points to even 50 and more percent. So what are we doing? I think most of you are aware or have bought some sort of wearable technology which has been designed for consumers. Apple Watch is an example. They operate under the premise of a physical sensing, optical sensing, which can then give you things like heart rate, perhaps temperature, number of steps. Our goal, our technology is actually based on chemical sensing, which opens up an entire set of new analytes that we can measure. So we're combining multiple sensors into one skin patch, which can be placed in different locations of the body. We just need one, and then analyzes molecules that have percolated all the way to the skin. Interstitial fluid has 90% the same characteristics of blood and lives right under the skin, just 1/50th of an inch under the derma, and contains sugars, acids, salts, amino acid, coenzymes, from small to large solute. So what's happening, and I'll give an example that is perhaps familiar with people, example of glucose, since nowadays there is a big hype around the glucose monitoring system. As we sugar, glucose enters the blood vessels and then slowly moves into the interstitial fluid. Same thing with the other molecule. There is a little delay of the order of minutes, but with our sensor we can detect this type of molecules. So what are the opportunities for us? There is a large range of potential opportunities. Electrolyte imbalance, dehydration, hydration states. Those are perhaps a little bit lighter weight problems, but we could potentially, in the future, tackle larger, bigger problems such as cancer detection. So where do we start? As a company, we are starting with the first use case, which is metabolic syndrome. A syndrome is not a disease. It's actually a combination of factors that taken one by one may not be so worrisome, but when you put them together, they become a real problem. Metabolic syndrome affects pretty much a large percentage, 1/3 of the US population, European and Asian population. It's growing very rapidly, and it's a combination of the factors that you see here in the slide. It's increased body mass that we can detect by tracking certain hormones, increased blood pressure, elevated triglycerides, cholesterol, and elevated glucose. So I will stop here for a second and just show you a prototype. Disclaimer, this is an early prototype. It's ugly. it doesn't look good, but we are a newly minted company. We started this year, and we're making great strides towards our first product delivery. So what you see here, there is no sound, so and don't mind the bottles in the back. What you see here is an example of a readout of the data in multiple channels. The application of the sensor is it's quite easy, can be applied with our goal is for the sensor, we're designing a sensor that can be used for multiple days with components such as a battery that can last 3 weeks to a month. A little bit of a technical slide here. As I said, this is a combination of biotech, computer science, hardware engineering. The sensor has a number of metabolic sensors, temperature sensor. We can add acceleration, some of the components that perhaps people are more familiar with. It has a power management system. It has a ultra low power EDA front end with a microcontroller. This sits in an overall IoT architecture where the data through BLE is moved to a receiving device, typically, a smartphone, and then data can be stored into the cloud. So I would not conclude my presentation without talking about what's the brain behind what we do, once we collect this plethora of data. We're also building in the back of this sensor technology a tiny ML system. What does that mean? It incorporates research, scientific data, scientific literature with a continuous understanding of your real-time data to produce some very personalized, detailed health suggestion it could be in the form of a report, or it could be in an interactive form for the clinician. So our goal is to serve the clinician with reports that he has never seen before. Additionally, down on the roadmap is also the ability to import third-party data sets as well. Quickly to conclude, our business model is based on a recurring revenue model based on subscription of the device. We haven't nailed down the exact cost of the device, so we know it will be, a certain affordable order of magnitude. The cost of goods, it's quite low. We're talking about less than $10. We are working with medical distributors. We're in a kind of a clinical trial phase. We are hoping to deliver version 1 of the product at the beginning of the year. Right now, we are working with a number of labs and academic institution to continue the research. From a hardware standpoint, we have a partnership with electronic manufacturers like analog devices and PalmSense. For the actual sensing technology, we're partnering with ISF Labs, which is a company that specializes only in the actual collection of the interstitial fluid. We were lucky recently, we got a great partnership with the University of course, we have a great partnership through Ron John with Stanford. I shouldn't forget to mention that, but we also have a great partnership with the University of California, where we got a bunch of researchers working and collaborating with us. Here is the founding team. It's myself, Ron John, Cristina D'Aleore, who's also in the audience here, just recently joined, comes from NASA, 20+ year career at NASA, expert in sensor technology. Mark is our head of engineering, and we have an advisory board that spans, the medical field, angel investors, people, business, as well as a scientific advisory board. So we're looking to raise $3 million at a $6 million evaluation. Most of the money is going to go in R&D, validation study, prototyping, expanding really the sensor, the capability of the sensor. As I mentioned, there are lots of different applications that we can knock down one by one. And that's it. So if you want to learn more, talk to me. Christina is in the audience, or just scan the QR code.
Questions? Thank you very much for a great presentation. Can you share a bit more? Is it even possible to track neurotransmitters? How can you be sure about that? Neurotransmitters.
Yes. So although I have to say this is not our primary goal, yes, there are neurotransmitters in interstitial fluid. Dopamine is one of them. So what is the premise? The fundamental problem you're trying to solve is really trying to understand how the concentration in the blood relates to the concentration in the ISF, because those are different. What we know is that they vary at the same time. They are correlated, but the concentration are different. So yes, there are neurotransmitters in ISF. At what stage?
Yeah. So
right now, our first and important focus is really about metabolic disorders. I also have a background more in cardiovascular science, so that the two things kind of come together. I don't know, talk to us maybe mid next year.
Okay, thank you very much. Wish you all the best with the
Thank
project.
So we're in the process. So we're doing tests right now. So we have, so one of the nice things about interstitial fluid is that it can be handled relatively easy. It doesn't coagulate. It's fairly stable. So one of the analyses, we're doing a lot of studies in parallel. So one of the analyses that we're doing is not only the stability, but the concentration studies.
If you need a human trial, let me know. I can be subject.
Thank you. Yes, if anybody wants to donate, I have a video. I didn't show it, but it's completely painless. It's not, the sensor doesn't touch the nerves, it doesn't touch the blood. So it's really, it's really non-invasive. Huh?
Have tried this before. It looks like a very exceptionally, complex problem.
It's not an easy problem. As I said at the beginning, it's a little bit of a moonshot. But if you look at literature and you look at a simple time series of literature over time that talk about ISF, the bulk of the papers that have come out in the last few years. I mean, there is a very, very strong interest in really understanding and leveraging this as a potential. Nice to see you.
So don't you need to get some key opinion leaders to try to resolve the dialogue between blood and ISF? I mean, isn't this a major part of what you have to do to kind of like, evangelize that there is, isn't that a huge task?
Yes. So in the advisory board, we have, we have specialists, we have people that have, that type of, experience, and then we have Ron John, of course. But talking more seriously, it's it's really not about just re-educating, but showing the physician that there is another tool. I mean, I don't think anybody would debate the fact that these biomarkers change so rapidly. This has been established, has been studied, everybody knows. I mean, there is probably, and I'm going to dare saying there is probably not a single data that comes out of the human body that doesn't vary, even temperature, simplest as temperature. We have, there are different estimates, but one conservative estimate states that the human body releases between 20 and 30 gigabytes of data just from the surface of the skin. So who's analyzing that?
Hi, Sylvia. Great to see you again.
Great to see you.
You said,
by the way, Tom and I met here, but we worked together at HP 10 years ago?
many years
ago.
You mentioned some sort of AI, I'll call it an AI engine or something that you're building into. What's the purpose of that versus leveraging all the investment that's going into putting those into mobile devices today?
So the question is that what do you do with the data? And it's a lot of data. So the pipeline is you don't get data, you get a signal. That signal from the sensor needs to be transformed into some sort of readable, human readable, physician readable data set. Yes, we can present to a doctor just a bunch of time series of, this is the trend of this hormone, leptin, adiponectin, and so on. But I think the sweet spot is to really being able to correlate, intelligently correlate these measurements. I'll give you an example. It seems like the sepsis as a word has been, the favorite in the previous session. So infections, as an example, could have some. So when people, get this type of infection, typically they have a drop in blood pressure and an increase in lactates. So how do you correlate these two events that we monitor to produce some interesting, outcome?
Yeah. Congratulations. Definitely very, very interesting. I'm coming from another industry. I'm coming from games and AR and VR, etc. But thinking about this and quoting maybe Kevin Kelly's quantified self, I understand by your presentation that your priority in terms of target market is mostly on the clinical side, on the metabolic side. Do you see any future, and if you do, when, for gamified, quantified self features for this type of data, especially if you are including and incorporating ML and LLMs as the interactive element for the user?
So you're asking if if we're thinking of a gamification.
Gamification is like the last mile of that, right? The last mile. What I am asking is, do you see at some point a broader target market that is beyond clinical and is more like the quantified self kind of market, which is not sick, not in need? Quoting your slide, is not people in need.
Definitely. I mean, I would love to sell this to consumers, but I'm acutely aware of a couple of major challenges that some large companies have shaped the consumer wearable market to think in a certain way, to think that the number of steps is the most important thing that you need to do. Then you need to, if your heart rate goes up, then it's bad. Reality is that when these biomarkers change, high doesn't necessarily mean bad and low doesn't necessarily mean well. So in order to approach a consumer market, we need a level of, and I'm going to use the wrong word, simplification of the results that is useful yet not dangerous to a consumer.
Okay, thank you for Sylvia and X10E. So the next company will be Superbio.
All right. Hi, everyone. Good to be here. My name is Perkins. I'm the CEO and co-founder of Superbio with Ranjan Nag here. So Superbio is essentially a company that is building an AI scientist for drug discovery. What does that mean? I'll first ground you in reality before I talk about what we're really building. And I'll talk about something. I'll tell something that you probably heard over and over again, which is it is very expensive and it takes a tons of amount of time to take drugs to the market, billions of dollars and up to 15 years. And if there's one thing that ties all the companies that you listen today, the biopharma companies or pharma companies, this is what they care about. They care about getting better drugs to the market faster and more affordably. And the way to do that is to actually improve your R&D outcomes, right? And there are 5 ways you can do that. You can improve the speed. You can accelerate your time to your milestone. You can improve your success, right? You do it out of like 5 times instead of trying 50 times. You do it in a scalable way. You can get, 500, 5,000 targets at the same time. You can get higher quality and you can drive efficiency and reduce your costs. But the reality is, about 70% of scientists believe AI can really help with speed, success, and quality of R&D outcomes, but only 1 in 5 biopharma is using AI regularly in their R&D. And that is because, first of all, there's not many built for science technology. Scientists, data scientists working by pharma companies, they're limited with generalist tools that they're provided to be able to analyze data. About 56% believe that non-standard interfaces are a hinder in AI adoption. Secondly, collaboration is challenging. Drug discovery today is a multi-team sport. So you need data teams, lab teams, manufacturing teams to be able to work with each other, to be able to improve your R&D outcomes. And 41% of scientists really cite it's extremely challenging to work between lab and data teams. And finally, there are major skill gaps in the industry, meaning that success depends on the talent that is using and working on the technology, but we don't have many great technologists in the industry today. So what Superbio is essentially an intuitive and collaborative AI platform for R&D powered by an agentic AI model. This means that first and foremost, we provide easy and instant access to hundreds of best-in-class AI models, which essentially eliminates the need to build IT infrastructure on the user's end. Secondly, we not only serve you really nice, easy-to-use, high-performing models, but we build the software around it that allows you to efficiently collaborate and improve the quality of your R&D between data teams and lab teams. And finally, you can customize this generative AI. You can customize your AI models using your own fine-tuning, using your own data and fine-tune it. So what we're building is essentially this AI scientist that really understand the needs and offers solutions and run those solutions for you. So just to break this down, this is some of the experiments that we've been running at the company, not only offering models, but really building an AI scientist over them, where a scientist can come in and say, hey, I'm working on a design drug targeting, PCSK9. What AI tools can help my research? Can you help me do that? So, and the Superbio basically can understand your use case, search the entire Superbio database of AI models, tell them what they can do, and basically ask you at the end, hey, why don't you upload your data and let me run this entire pipeline for you, right? So this basically insulates the entire complexity of how to run an AI model, how to deploy it on the infrastructure. All of those are done by this really simple, easy to use conversational interface and AI scientist at your disposal. So where we're today is actually this software that is built by scientists that are for scientists, right? We offer over 650 best-in-class AI models served in a very intuitive graphical user interface that allows you to collaborate by sharing results, sharing comments, sharing data sets, as well as orchestrate these AI workflows in what we call a data hub, right? It allows you to access to your proprietary data, public data, and finally, you can bring your own tools. You might have your own machine learning team, your AI team, and you can bring your own tools and take advantage of the entire key features that you see on the slide today. So what can I do with AI, you might ask, or as a scientist might ask? So these are some of the use cases that gets the highest traction on our platform today. For R&D, you can really model how a protein interacts with a DNA, how a protein interacts with an RNA. With RF diffusion protein MPN, these are, by the way, if you've heard a couple days ago, David Baker from Institute of Protein Design won a Nobel Prize, and he is behind most of these models at the top. Rosetta Fold, RF diffusion, protein MPN comes from Baker Labs Institute of Protein Design. So these are all open source models, but we serve them in a really easy to use interface deployed on an optimized infrastructure. So you can also model how your molecule docks into a ligand. You can review literature. You can access hundreds of thousands, hundreds of millions of articles, ask a simple question and get instant answers, as well as run some downstream single cell analysis tests today using the platform. If any of you, a biopharma company here today, and you might say, hey, I don't want to really give you my data. I just want to tell you that our data is handled with the highest security, utmost security standards, right? Each of the users has a private sandbox. No other user, including our team, has read or write access. The data, this is asked many times, the data is not used to train any data, to train any models. We're not using it to train or fine tune our own models. And finally, by default, if you send any data to our inference services, we delete it after a certain amount of time, right? So again, for the biopharma companies out there that are listening to this, we have this early access program, right? This comes with the platform, the best-in-class AI models, basically a profound influence on our product roadmap because there is not many companies in there right now. We're working with only a select few, and actually an AI team that can help with everything, data, performance, bringing in models for you. So anything and everything that our team can help is as part of the Superbio early access program that lasts for 3 months. So today we're actually seeing significant customer interest. We kept the platform open and available for beta users. So we have about over 3,000 beta users today that are from Sanofi, Pfizer, Roche, as well as one commercial partnership and a few in the works with the likes of the great Memorial Sloan Kettering Cancer Center. And we actually have 3 organizations today in the early access program. So we have spot for 2 more, and they're highly coveted. So if you're interested, do let me know. So how do we make money? In a variety of different ways. We really innovate, not with the product, but also with the business model as well. So if you're a company and you're like, hey, we want to be able to use your models, we just tell you, that's fine. We provide you tiered access to key features around seats and infrastructure and computing hours per month. But if you are a tech company, if you are a like an academic medical center who has their own model, but you would like to commercialize it without losing your IP, what you can do is you can actually embed that to our platform, hide your IP, and commercialize your tools through our platform, and really name your price, and then Superbio basically will take 30% of the net revenue on top of that. So commercial partnerships is another way that we bring in money. So if you look at the industry today, really current offers for scientific AI and collaboration is quite insufficient. If there are any, AI heads out there, Hugging Face is this generic model library. They're really valued at $4 billion, but you would rarely see any medical tools in there. So today, not only do we have and offer all of these models in this infra with no lift for setup, but we QC them as well. So it's reportedly from our users, very easy to use and very easy to get started with, as opposed to some of those different tools that you see on the platform today. So as I mentioned, I've co-founded this company with Ranjan, but we also have some wonderful advisors and team members that works with us. And so we pack over 50 years of bio, AI, and business expertise in one team, and we're actually looking to grow today. So to finalize, we are raising $1.5 million at 12.5 million pre-money. About 300K of this is closed. You might ask, why so little? Why so, why so early? That's because this is R42 group friends and family round. So we're going to actually close this quite quickly and then soon thereafter, go raise a larger round. So if you're interested, please talk to me afterwards. And where we will go with that money is actually, we are scaling our revenues. Essentially, we'll all do way to $2 million revenue, 10 10x the number of users that we have on the platform, and really 10x the number of solutions we have as well. So what we're building, as I mentioned, is an AI scientist that is for drug discovery. So do join us as we enable a world in which drug development is 100% powered by AI and collaboration. So thanks for listening. I'll take questions now.
Thank you for the presentation. It sounds like you make many open source models available, including through your partnerships.
Mm-hmm.
Do you have your own LLM that's like a coordinator or like a agentic AI? Or are you using a
yes,
one of the main providers or?
Correct, yeah. So the way that we actually orchestrate the AI workflows is this new agentic AI that we're working on that allows you to, that basically taps into your data hub, pulls in your data for you, sets your parameters, and to run the models and the pipelines for you. So all the key features that you see on the platform is actually orchestrated and done by this agentic AI that we're building.
Hey, Berkey, how many third-party technology partners do you have in the store?
Currently, we have MSK, and then a couple ones that we can't that announce just yet. Third party for commercial ones, do you mean?
Yeah, commercial.
Commercial ones.
Yeah.
Not the open source ones. Yeah. Sure.
Very closed loop platform. Right? It's not an open source kind of platform, right?
So the
model.
Anybody can come in and contribute a model. Yeah. We just quality control the model before we deploy to the platform. Yeah.
So you have basically two systems. One is functionalizing yourself.
Yes. Yeah. Exactly. So the question is, what type of models do you offer and how do you monetize on them? Open source models and closed source models. Closed source models we monetize through the commercial partnerships and revenue share. The open source models, really the value there is the infrastructure, the collaboration software, and the ability to run these really efficiently.
Oh, okay. So, I think what I have understood is you have So it looks like you have basically collected a lot of models, right?
Correct.
From everywhere. So now is this all this model basically is it being standardized? Standardized means, for example, I have all these model requires, say, one function that I want to use, right? The same function can I use across all models, if, for example, for the data preparation, something like that.
Mm-hmm.
Standardizing every function that works for all the models, or every model is created by individuals and then everybody has a different function for the same output?
No, that's a good question. So we built sort of data utility functions that allows you to, that basically makes it easy to not only convert your data, but makes it applicable to different set of apps with the just same data set, basically. So let's say you want to run single cell analysis, right? You would need what you call the H5AD file. That all of the apps on the platform works with H5AD files. So you have like broad, general, workable sort of data utility, data conversion capabilities.
Here, very quick, 3 questions. Number 1, this is web-based, right?
Web-based, yes.
Okay. Number 2 is I'm not familiar with these models, obviously, but are these also available in other languages like Spanish and Portuguese?
The platform is not.
Maybe the platform, no, but I'm
not
talking about,
currently,
like,
but it could be, yeah.
Okay. And the final question, it was quick, I told you. Vectorial database, I get all this in the model side, but how are you? And I have clarity that you are going to delete the data from all this,
Sure.
but is a vectorial database or?
The vectorial database is for the app.
Just for your
for the
platform
models, just for the,
specifically.
yeah, exactly. Yeah.
Yeah.
We don't like hold or vectorize the data from the users.
Okay.
Yeah.
Got it. Thank you.
Sure.
Congrats.
Happy to, thank you. Cool.
Okay. Thank you, Burke and Superbio. So we are going to have today's the last presentation, and it's actually another R42, not portfolio, but incubated salt tank from the R42 Institute. Welcome, Dr. Anil.
Thank you. Wait, do I need this one? I just need that one. Yeah.
Freestyle.
Yeah, freestyle. Hello, everyone. I'm Kim Parnell. I am a part of the team that we have worked on to put together competition or a submission for the XPRIZE Health Span Prize. It's a very interesting and innovative competition. So let me tell you a little bit about how we got started. So we started out this summer under the R42 Fellows Program. And we had a team with a variety of backgrounds and range of ages and everything. Katerina is here. And of course, our leader and mentor, Dr. Ranjan Nag, is here. So this is how we started out in the R42 Fellows Program, and we've been continuing it to try to, evolve it into a submission that we can have on the XPRIZE. So let me tell you a little bit about what the XPRIZE itself is for the health span competition. So it's a $101 million prize, 7-year global competition with the objective to increase health span, not just living longer, but living better also. So there's some pretty lofty goals definitely here. So you must give your therapeutic in 1 year or less and try to prove a 10-year minimum increase in lifespan. There are 3 main components associated with it: immune, cognitive, and muscle function tests. These are all part of what's being used to evaluate this increase then. And what we have attempted to do is to put together, we've called it a super team, partnering with multiple other R42 portfolio companies, and several of which you've seen in much greater detail here today then. But we'll show you a little bit more of the high level part. So here's what we have in terms of kind of timeline for it. It's starting out now, and our first deliverable is a submission, an application that will be due December 20th of this year. There are some separate kind of, I guess you would call it, gating or qualifying steps then beyond that. So based on that submission, there will be a selection of 40 teams to divide a $10 million portion of this prize and to start to do some proof of concept then. There's also a separate part associated with muscular dystrophy. That is $10 million totally separated there. So the groups would start then in 2025, the ones that are selected, there'd be 40 selected to divide $10 million. And they would start to try to do some proof of concept. I'll show you a little bit about our thoughts there. The next part is basically a year out then. And out of that 40, there'll be 10 selected, and they would divide a $10 million milestone prize. So they would be able to, utilize that going forward. That'd be out in mid-2026, basically then. And then after that, it'll go on with, more detail in terms of the types of application of the planned work and attempting to show the growth, the increase that we're looking for then. So how do you win it? It is truly based on the 3 key things. There's cognitive part, that's obviously a very important part. Muscle is another very important part, and immunity. And you've heard a lot about these things today in terms of different applications and different ways that they're applied. So some of the way we're looking at or thinking about testing that can be utilized to evaluate these things, this is kind of in these same three categories then. So in muscle function testing, we're thinking about endurance capacity, peak VO2, blood oxygen level. You know, you've heard about that, the importance of oxygen, definitely. A lower body power or rate of torque development, that's another type of test, kind of a direct measurement of muscle. And then muscle mass that can be measured through a D3 creatine dilution type of measurement. And so these are tests that can be applied to evaluate this aspect of the applied, you know, therapeutic and therapeutic and supplemental types of applications. Then cognitive, what we're thinking about are the like a cognitive summary score, an NIH fluid composite type score. This is something to help to evaluate evaluate cognitive function testing. There's other ways that can be done, neurogames, blood biomarkers, genetics, brain MRI. There's other things that can be done. But, you know, overall, we'd be looking for, especially in the early going, you know, relatively simple types of things that can be done then. And immune function testing. So again, very, very important. Like an ex vivo native immune response, this would be one component. Immune cell composition, this IMM age score is a way to evaluate. And inflammatory status or SASP index. These are things that can be used to help to evaluate immune function and levels there. So preliminary, just potential advisory board members here. We'll also need some type of institutional review board, IRB, as well. That'll be another thing that'll be important. So as of when we did this presentation for the R42 Fellows program, these are some of the teams that we have talked to and looked at in terms of being a part of this super team, a part of this coalition. And as I said, you've seen some of these here today in greater detail. So everything I'll show you will really be pretty high level then. And there have also been some other additions since we did this presentation. So give you one Keto Swiss. This is a supplement that can be used to basically somewhat simulate the effects of fasting or dieting. And so how does it hit? How does it apply? Particularly cognitive is one of the applications there. Also muscle is another aspect, but this is one that can be used to induce ketosis without fasting or dieting. So it's a supplement that can be utilized and something that can be available early on then. Agemica, you heard some about earlier today. A vaccine for aging is a target there. How would that apply? That would apply in terms of immune function and also in terms of muscle function, particularly in that muscular dystrophy aspect then. But that's another one that can be important. Matrix, you heard about here earlier. So bioreactor grown mitochondria, how that can be utilized. This really can apply to all three portions here. cognitive, muscle, and immunity aspects. X10E, you heard about earlier. So X10E, very important in terms of tracking components, wearable sensors, being able to track data associated with these various components in. This is also a very important one. Track biomarkers, track overall health in a number of different categories. We see this as being particularly important. Swaza, you heard about earlier, improving oxygen level, particularly important for muscle and cognition, these aspects here. Rubido, this would be one that targets senescent cells or zombie cells and helps to remove them, so improving immunity. NeuroAge, heard a little bit about earlier as well, utilizing AI to discover drugs that prevent brain degeneration. Cognitive, big effect there in terms of cognitive aspects. Melio is a company that has supplements that help with cellular cleanup and can improve muscle function and immunity as well. Superbio, you just heard about. We think that that can provide kind of overall support, helping to check and optimize the various therapeutics across the platform that we're putting together. So what are the first parts? The first part in that initial milestone, if you will, part, this would be a relatively short adaptive trial to try to get a sense of where we're going, where it can go. Short trial, 30 to 60 days, small group of people. Need to do it as inexpensive and be able to help to kind of test out some of the approaches that we have and fine tune based on this proof of concept to go into the longer trial. Final trial design, this would be a bigger deal. This might be on the order of 100 people. Age range for the XPRIZE are in sort of the 50 to 80 range, and we would expect we might have an average age around 75. So this would have 3 months of baseline testing, like a pretrial baseline testing, and then based on that, 1 year of interventions and more detailed testing then. So how the baseline testing might be done, short tests, 1 month intervals before the trial start, monitoring devices, things of that sort, and being able to do cognitive and peak VO2 tests would be done remotely then. Trial intervention design, randomized groups, being able to utilize things like diet and exercise, but also utilize these other components that we're talking about. And with the final rounds done in much the same way. So interventions can't include the measures that you're using for endpoint assessment. We have to be safe, have regulatory approvals, and be able to recruit and add new members along the way. But largely, your application needs to specify the things that you may be able to use, that you can't come back and add things along the way then. And finally, just to give you a sense of the XPRIZE itself, it's truly a global competition. This is kind of the way that these teams are dispersed around the world, gives you a sense of where they are. Truly a global competition then. So I will stop there and try to answer any questions, get help from others as needed. So thank you.
Thank you. That's a very interesting project. So any participants in the study, subjects, would have to stay on board for the entire 7 years of the project?
Yeah, that's a good question. I haven't really thought about that. I mean, I think that certainly when you get into that last set of participants, you know, you would want to be able to track them through at that point. That would be the goal, the desire, I think, to be able to do that.
Second part of that is just if you could comment or have any thoughts on it. In 7 years, someone who is, say, 65 years old could change a lot during that period of time. And will these studies be adjusting for the natural aging? Or I'm just wondering, like, oh, there's going to be improvements on aging, but by the way, people are going to be aging anyway.
Yeah. That's a good point. I don't know how that could work. As I said, we have to kind of define the things that we're going to utilize and, you know, be able to go from that. But you're right. You know, there's aging that's taking place during that time and everything. Yeah.
Sorry, quick question. So you're enrolling trial patients now or soon? So it has to be existing drugs only, or so you can't have a new therapeutic or part of this program, right? Is that correct?
The therapeutics are the more difficult part, and you know, with the companies that we were showing, you know, some of those are definitely not available now, and you know, question of when they can be available. The supplements are the things that we can utilize more early on, but I think we can, you know, provide some ability for these things to come in as long as we specify them in our application. That's kind of the key thing.
So you can, right now, clearly, if you're doing a new therapy, so you have to go with what you have got, right? You have to go with what you have got, which is some supplement companies we've got in our portfolio, exercise regimes, diet regimes, lifestyle regimes. But then as they come about, if we include it in the initial proposals, my understanding, then we can add them to the trials as they appear.
Yeah.
So as they get to have to be a phase 2, really, then you can start including it.
I mean, really, that second portion of the trial may be kind of multi-level, I guess, in some sense there. Yeah.
Yeah. All right.
All right.
Okay.
Well, thank you then. Thanks, everyone.
Okay, thank you, everyone. This is our last presentation. And as I said, please scan QR code and express interest in any of the company, and we'll connect you with them after. And welcome the Appleton team.
Thanks, everyone.
Yes. Okay, thanks. Yes, that's Ishran, Anastasia, everyone. And of course, Armin, we're finishing off. Thanks for all coming. And we have a number of those of you, some of you are regulars, but some of you are new. You're now on our mailing list, so you'll get lists of things. I think almost every 6 weeks or so, we have some kind of webinar on some topic, usually either on aging or venturing. The next topic is going to be on using AI for grant writing. So if anyone is thinking about that, we have a company, Next Thought, that has got a GPT system for writing grants, much quicker and easier. But there actually is going to be an educational talk. All our talks usually in the webinar series are educational. I think Sylvia gave a talk, for example. I've given several talks on various topics. And so you're all welcome to those, and there'll be things. So what I want to be trying to say, give you this vibe that it's an exciting ecosystem, and we look at tough problems, moonshot problems. This is not really form-filling enterprise software type companies. I'm sure you have some of those as your clients, and they make lots of money, I'm sure, very successful, but it's tough tech. It's tough tech. And it's sort of a self-selection thing. If people are interested in those kinds of things, and you'll gravitate to our activities. and we have fun as well, but at the same time. And the second opportunity is the fellowship opportunity next year. Okay, Armin, any other words? No?
This is not for the faint of heart.
No, for the faint of heart. But you know, you'll be able to touch things that are extremely impactful. Okay, so we'll see you in probably other events, right? A few healthy snacks left and a few Diet Cokes, caffeinated.
So following will be the networking section, and the venue will be closed by 6 p.m. sharp.
Armin kicks us out.
Yeah. So just be wise with the time.
So, yes. I want to be. Okay,
Hello, good to see you.
Yeah, you too.
See you later.
Yes.
What is your exam?
It's on every slide, but Ron John and okay.
How did it go?
Yeah.
Yes, my talk is the best.
That was good. Your talk was good.
Yeah.
The help scheme.
Oh, yeah. Yeah, it's hardly whatever. Do you want to try it? Look at this.
Put it on my hand.
Yeah, let's do it. You're already oxygenating them, right?
Let's talk about, it's actually the New York Times. Is it this morning or yesterday? 33 birds.
Yeah. All right. Yeah. That's right. Yeah.
One page
Placenta is actually very good at.
Yeah, it's like every day.
See, pretty cool.
Anastasia said they threw away.
Yeah.
All right.
Anyway, that's it. It's just an oxygenation. I want to know I'm COPD because my mother has COPD. And, I'll show you the human dose. You really can deliver. Like she paid $500 or $500. This is the human dose. Yeah. So, I mean, the price that I quoted you right now, it's just the prices at production for kind of our small scale trials. When we scale it up. Yeah, I could imagine like her just taking the mask every day. Yeah, I mean, not even a mask, you just nebulize it. Yeah. That's the goal. Like, we have a lot of physicians that work with. They're like, the biggest aspect of stigma. Exactly, just like not good money. COPD, ARDS, all of them are airway related. What happens to bacterial? Your body so as part of our thinking work, phase 1 is going to be in healthy volunteers, but we're doing a phase 2A and COPD patients. As a way to kind of show that it will work the same way. Try to get it. The faster we get money, the faster we go, right? I think it all works the same way. If all goes well, so we already we've already had a discussion with the FDA. We know like the plan there. So we're gonna use Australia human data plus our animal data here for submission. So phase 2 in 2020. 18 months. Yeah. And then after that, market authorization for 2023.
It's almost the same price.
Yeah. Takes a while. It's most of the bigger PATs. Yeah, it's not so much like, this is ready to. It's the time of how long you have to each stage of the time. It's not necessarily, what's your background? Are you based? Yes. Okay.
As a general manager at HP, got into healthcare at Cerner. And got through 3 activations, plus 3 jobs, basically. And now I'm hanging out, learning about longevity. Partially retired. Got it. Trying not to retire, but or say the words anyway. Yeah. New chapter. Yeah, trying to figure out what to do next.
Have you done the DCI? The DCI program.
Yeah.
You told me. It's like, you got to hang out with a bunch of college guys, right? Just do whatever you want.
It's whatever you want, part of it.
Pretty much yeah.
I was just wondering.
I think it's definitely a benefit program. It's very much like just before, find what you want, what's interesting to you, to us, they think are interesting. Yes. It's a very close program that they have. And then they're like, well, what do I do now? Well, I'm gonna just go and see what's happening.
That's a fun thing. You and I've met this before.
Maybe 100, but
I was trying to think. 40 years ago.
Then when it started with like, can I just do this?
Neural networks. It's really small. It's all basically theoretical.
Yeah. Well, it's kind of. It's like, it might be in. Yeah, yes, the question is what's going to be the next thing? Like that. I got somebody who's working so quickly.
I'm a huge believer that this is, it's a major change. It's like when the internet hit, a major change that happens.
Yeah.
My kids, you don't have to be a data scientist. How to use these tools because you're going to need it. Every job you have.
Totally right. So understand at least what they're doing. Basic options.
Yeah.
Absolutely. No, I agree with you. So, we didn't put for like spots.
Yeah, go. I'll just bother them.
Yeah, go for it. Hi. Shall we? Let's stop over here. Nice talking to you.
Thank you, George. I'm gonna ask him some questions.
We should get you in very tight, actually. We should get you involved in the IEEE or something. Yeah. They fly these places. Go to the meetings and they're okay. Might be an answer. I'm happy there was something. I mean, done in this sense. So, like,
Very quickly. Thank you so much. Two questions. One, what do you think for the?
Yes, correct.
Really?
Yes. Oh my God, that's correct. Oh, yeah, mine too. Yes. I've got a meaning. I need to send you. I've got all these. No, I definitely need to send you. These were venture funds.
Yes, I invest in games. So I started by one charges.
DA, right?
That's here in 2006 and I started.
Okay.
So we started after being best in games.
Yes.
Now we are in prospect.
It's less competitive. The good thing is, we have basically zero, each one of these is zero competitors.
I'm fascinated by the space in the games. Yes, yes. I mean, it's fun, but definitely. So longevity and wellness. One of them is actually pretty decent in terms of, like traction. It's a CBD and wellness company that is products that are based on longevity. So I would definitely pick your brain. Thank you for asking. As you notice, I'm learning.
No one knows how to solve. No one knows how to solve.
Mario, nice to meet you. Thank you so much.
Oh, thank you, Mario. We'll have you on it, mailing.
Yeah, because there's another.
Oh, yes, there is a January. Yeah. Sign up that before November 1. Yeah.
Thank you. Nice to meet you.
Okay. Yes. Terry, right, yes, right.
Russia, I'm gonna go.
Taco. You can't improve cost. How can you improve? How do I raise my taco? Let him give you a presentation. Yes. I'm working Skype. Yes, I know. I'm advising Skype. I'm not advising you. It's like just diet exercise. I did that diet exercise. So we'd actually, I didn't know. Have you done a test? Diet exercise. That's the only way I know. So there's companies that my question. What's your commentary over? Protein. You use protein to do that.
Yeah, you can essentially inject the protein in 5 minutes. I think a lot of the effects they see on bicyclists have been
This is huge. Huge. My major assessments. That's about 7 steps. Yes, things are in high school. I'm not giving the same hard time. So basically, most things that we're working with, they never translate. And we've got to figure out why do you think. Why do you think this for 10 years?
Basically, I work on that. Yes. This is like the highest profile best match.
We had 80% before that. Would disagree with. Mitochondria guys.
Mitochondria guys. Oh, no.
Yeah, you're a young classic.
Oh, no.
I spoke with Brian Johnson.
What does he know? He hasn't even got a PhD. Yeah,
My co-founder is
so you got PhD. That's better than you, actually. I want to introduce you. Good luck with my jokes. She laughs at my jokes.
He already likes you because you get his humor.
No, that's
no, but I was anyway thinking I have to introduce you. She has a very interesting company. And by the way, was a Steve Horowitz lab. Because he has worked on some of the stuff that we did. But her company is something different, and she's going to tell you about it.
Okay. You're right. You're right. Yeah.
It's
on mice. Worms. Worms are even worse.
Humans.
I did invest in.
No, humans.
No, I invested in. They only had worm data. I still invested.
Oh no, we're beyond worms. We're on human.
No, you're
yes.
We do spinal cord transplantation.
Spinal cord transplant.